Anyway, and asking permission from everyone. We are presently recording this conversation. Okay po sa inyo?
Yes po.
Okay, very good.
Yes,
So
Doc.
again, hypothesis testing entails steps in order to arrive at a good result or an output. No? Where in hypothesis testing, we are going to test the hypothesis and eventually make a conclusion. So again, can you recall the first step doing hypothesis test? What's the first step doing hypothesis test again?
Organize data.
Okay, so we have to organize your data. Again, the objective of organizing data is that for you to have a basis on your choice of your statistical test, right? Okay, so when we say organizing data, the thing that you need to do here is you have to recognize first the distribution of your data. Okay, we have the normal, abnormal, because this will dictate the choice of your statistical test. Second is the type of data that you are dealing with, right? Are they qualitative, quantitative, okay, nominal, ordinal, interval, ratio? Again, the type of data will influence the choice of your statistical test. And then the next one is sample, right? The sample depends on how many variables you're trying to do. Then again, this will state the statistical test, okay, that you're going to use. So after organizing your data and giving a hint of the pictures of this data that you're going to treat, what would be the next step that you're going to do in hypothesis testing? That's the second step.
State the hypothesis.
Hypothesis.
You have to state your hypothesis, because your hypothesis, especially your null, okay, will be the decision in whether you're going to accept or reject this one eventually. Okay, so after having hypothesis, just like any thing in life, before you start doing anything, what will be the next step in doing this hypothesis testing?
State the level of significance.
Okay, of course, you have to state your confidence. No? How confident are you in doing this research? So it is your confidence level. So once you state your confidence level, okay, you also elicit your significance level, right? So your confidence level would merely pertain to the null or the hypothesis, or the population, and significance level will be the probability for your population as well. So this comes also with the alpha level. Okay, so again, you can choose any level of confidence that you want in your paper. Okay, that there will be no problem. Okay, you can always elicit the equivalent percentage or equivalent values for each, but we were able to learn that we can use the empirical numbers, because which starts at 90 to 99, 95 in between. Okay, and these are preset numbers with equivalent confidence level, equivalent significance level, alpha level. The good thing, if you can use this interval or the range of numbers, is that it will eventually affect the possibility of error when you are making your decision. Okay, so if we use these empirical numbers, you will be able to balance what type of error you're going or you are willing to commit. Okay, so if you want a bigger alpha error, then you have to decrease your confidence level, right? Or if you want a bigger beta error, then you have to increase your confidence level, and your significance level will follow as well. Okay, do you still remember that two types of error that we will be able to commit if we make decisions? Okay, just like in any part of our life, two types of error. When we make decisions, we are always uh, faced with the possibility of making a wrong decision. Okay, right decision or wrong decision. It's either we decided the right thing when in fact it will be the other way around. Okay, so these are errors that we should be ready and we are willing to commit when we do our research. What are the two types of error again? You still remember the two types of error that we possibly can commit in doing our papers?
Alpha and beta errors.
Okay, the alpha and the beta error. The alpha is your type 1 and your beta is type 2. Okay, type 1 is usually your false positive or the producer's risk. Okay, your type 2 is false negative and consumer's risk. Okay. So can you give me an example of a type 1 error or making a wrong decision on a certain aspect? Can you cite an example what a type 1 error is? Please remember that type 1 error. You commit a type 1 error if. Can you give me an example? Mukhang inaantok pa sila. That is type 1 error again. Okay, let's take it in a context. Do you still remember the COVID vaccine? Being the doctor? Producer's risk.
Sir, parang yung type 1 error, parang you give out the COVID vaccine kahit na you are aware of the risk that may happen. Yun po ba yung sir? Parang ganon.
Okay, yes, but that will be type 2 error. Okay?
Type 2.
Type 2 error because you believe that okay yung gamot mo, okay? When in fact, meron nang nararamdaman hindi maganda yung pasyente mo. Okay. So the type 1 error is the other way around. Ikaw naman na doktor ang nag-iisip na baka merong effect yung gamot mo when in fact wala naman silang nararamdaman. Wala nang nararamdaman yung pasyente mo. Okay? So this is more the alpha error and type 2 is the beta error. So if you try to see the distribution, this is the alpha and the beta error. So the alpha error is when you accept, okay, or you rejected. You rejected the null hypothesis when in fact it should have been accepted. For the other way around, your type 2 error is you made a decision of accepting data instead of rejecting it. Okay? Because the truth is, it should have been rejected. Okay? So yun yung na-commit mong error na pag na-accept mo siya instead na dapat ni-reject siya. Okay? So this happens during extremes. No? So kunyari this is 90, 95, 99. So if you want to increase your beta error, what we're going to do? You also increase the value of your beta by increasing
The confidence.
So you widen it. Mas gusto mo mas marami kang makommit na beta error, then you widen the interval. So from one standard deviation, di luwagan mo, lakihan mo yung target area so that lalaki yung interval for your beta, and yung alpha naman will decrease. So if you want a type 1 error, mas gusto mong mag-commit ng type 1 error, what you're going to do?
You decrease the confidence interval.
So, it decrease the confidence interval para mas marami kang makatch na alpha. That's why it is called false positive, false negative. Kasi you're giving the chances na mas gusto mong magkaroon ng false positive kaysa false negative, or mas ina-accept mo na magkaroon ka ng false negatives kaysa sa false positive. That's what we're doing. So, the best way sometimes is to stay in the middle. No? So, you use 95 para ma-limit mo, sakto lang yung alpha, sakto lang yung beta. So, if you use 90, okay, masyado mong niliitan yung beta mo. If you use 99, masyado mo namang nilakihan yung beta mo. So, stay in the middle. I'm not saying that this is the best, no? You're 95, but still, if you are going to select your confidence level, might as well stay in the middle. Okay? Para balance mo yung possibility na magkaroon ng extreme error. Okay. So after establishing your confidence level, your significance level, and the alpha, what's the next step?
Determine the critical value.
Okay, you identify the critical regions of rejection. Okay. So, you establish your critical value. Okay. So, this will be either 0.05, 0.1, or 0.01. So, after establishing your critical value, what's the next step?
Select the statistical test.
Yes, because what is your aim in doing your
Determine the calculated value of the sample.
So this time, you have already established the margins. Alam mo na kung saan ka magta-target. Alam mo na kung saan lalagpas yung error mo, yung decisions that you're going to make. You have set your boundaries. Now you're ready to look for the value of your test. Okay, so you calculate now the calculated value of your test. Okay, so if you do your calculated test, the main aim is to establish your anong hinahanap mo sa calculated value ng test? Anong hinahanap mo? The what? If you are doing the testing, anong hinahanap mo? Ultimately, it's all about the
P-value of the sample.
Of the sample or the calculated value. Okay, so your p-value and calculated value of your test, you will use this to compare with the p-value of your
population
or your null. Then eventually you can make a decision. Okay, so in so doing, when you calculate your sample p-value, the sample or the calculated value, this is your sample. Okay, in doing this, you are faced with a decision of what statistical test you're going to use for that particular set of samples. Okay, so in choosing a statistical test, there are three things that you have to consider. Very important things to consider in choosing a statistical test. Just to remember that it will be based on these three things. What are these three things?
Distribution.
Data sample relationship.
Okay. So you have to determine what type of data you're dealing with. Again, so are these qualitative or quantitative? Okay. So qualitative for the nominal and ordinal, quantitative for the interval and the ratio. Okay. Because this will dictate what statistical test you're going to use. Okay. So In statistical test, there are two types. We have the parametric, right? And the non-parametric. You still remember this?
Yes, sir. Yes.
Okay. So that your interval and ratio data are for
Parametric.
parametric test. Usually your ordinal and nominal are for
Non-parametric.
non-parametric. Okay. So your parametric test, can you give me an example of your parametric test?
T-test. Z-test.
Include your t-test, z-test, and
ANOVA.
ANOVA. Okay. So can you give me an example of the non-parametric test?
Square.
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 Okay. So after determining your data, what type of data you have, the next thing that you have to consider, which is very important, is
Make a decision.
mhm,
Sample size.
sample. You have to take a look at your number of sample. Okay, because if you have you are comparing one sample, comparing more than two samples, this will still affect the type of statistics that you're going to use. So if you're treating one sample to another sample, like for example, comparing it. So what type of parametric test that you're going to use?
Very.
Okay.
T-test.
T-test.
The
Z-test.
t-test and the z-test. So for example, if it is more than two, more than three,
ANOVA.
is the most
ANOVA.
okay, you use the ANOVA. Okay. So the third thing that you need to consider is what?
Relationship.
Relationship.
Relationship. Because again, the type of relationship that you are trying to elicit will dictate the type of statistics that you have. Okay, so it's either the relationship, are you trying to make comparison? Okay. Are you comparing one variable to another variable, one variable to another group of variables, or two variables, etc.? Okay, so if you are trying to compare, what would be the possible test that you will use here?
Correlation.
T-test.
Okay,
Yes.
so the example will be the t-test, the z-test, and the ANOVA, right? Okay, so there will be uh, uh, characteristics that are fitted for this type of comparison test. Your t-test and the z-test will compare,
Maximum 2 samples only.
okay, 1 to 2 samples. Okay, 1 meaning to say sample within sample. So yung class nyo mismo, pwede nyong i-monitor yung progress nyo before and after. You still remember that? The pre-test and the post-test. But if you want to go, compare your class to another classes are different groups, okay? So comparing two samples. So you use the T and C test. If you are trying to compare more than two,
ANOVA.
what is the most appropriate test that you're going to do?
ANOVA.
You use the ANOVA. Okay. And the other type of relationship that you'd like to study is,
The correlation.
yes, association. You are not trying to compare, but you are trying to show if one has an association with the other group. Okay? Like for example, if we increase the temperature, okay, will your sales with cold drinks also increases? So are they related? The relationship is, are they associated with each other? Huh? So if you are trying to elicit association, what will be the two most common type of test that you're going to use?
Chi-square.
Okay, so you can use your chi-square. What else?
Source.
Your,
Pearson's correlation.
okay, your correlation. which is exemplified by Pearson, and the other one is
Spearman.
the regression. The regression. So what are the differences of this test? Chi-square is used when you want to show relationship or association using what type of data?
Nominal, ordinal.
These are the nominal and ordinal. So if you want to put people into orders or group, then you are comparing people in terms of kunyari their gender. So you put them into group, it becomes nominal, and you're trying to show the relationship. If one group is related to the other, then you better use the chi-square. Okay. What about your correlation and regression? What type of data are appropriate for this one?
Interval or ratio.
So these are for the interval and ratio data. Okay. So these three, 6 to establish an association between two groups, okay, or within a sample. So the difference naman between a correlation and regression. What's the difference between a correlation
Positive or negative.
and regression?
Cause and effect.
Okay. Correlation, 6 to establish only
Relationship.
if these are related without saying the degree of changes when one or your independent changes and its affect to your dependent variables. No? So hindi tayo after kung kunyari ilang degrees centigrade ang tatas ng temperature at kung ilang gano din kadami yung itatas ng sales ninyo. Okay? So that will be for regression. So if regression will be a projection test because we will try to compare the relationship or the association of two variables if any increase in a certain degree of your independent will cause a change also in your dependent variable. Okay, so if I have to increase the temperature by 2 degrees centigrade, okay, will it cause also an increase in 10 glasses, kunyari, of cold drinks na mabebenta mo? So if I increase to 4 degrees centigrade, can you make a projection? So the projection would be another 2 degrees centigrade, so that would be another 10 glasses. So for every 2 degrees increase will be equivalent to 10 glasses. So pag pumalo na tayo sa 4 degrees centigrade, so most probably you can project na you will have you will have a 20 glasses na cold drinks na mabebenta. So that's why it is called a projection, a test. So it will show you the relationship in terms of degree. Your correlation will only show you that if there's an increase in temperature, expectedly there will be an increase in sale. By how much, we don't know. If you want to do that, you can project that by using your regression test. Okay? So are we clear on all those types? And then after your pang ilan na yan? Pang 7 na yata yan. So after calculating the values of your test or the p-value of your test, you are now ready to
Make a decision rule.
we are now ready to decide. So you have to make a decision. And there are decision rules. Can you state the decision rule using the p-value? Okay, what's the decision rule? Like, for example, at a given confidence of 0.05. Okay. So if the value of your null hypothesis is 0.05, any value of your P that is more or less than 0.05 will prompt you to what? About your null hypothesis. Okay. So if your the p-value of your test is less than 0.05.
Reject the null hypothesis.
Okay, so it will be somewhere here. So that will prompt you to reject your null hypothesis. If the p-value of your test is less than 0.05, baliktad yata tayo. If your test is more than 0.05,
Accept.
okay, you have to accept an null hypothesis. So this will be somewhere here. If your p-value of your test is less than 0.05, will be somewhere here. We're going to reject your null hypothesis. Tama? Are you still with me?
Yes, sir.
Yes po.
Okay. But in terms of a calculated value, if we talk about calculated value, so your p-value 0.05 will be equivalent to a certain
Critical value.
critical value. Okay, if you can still remember, a 0.05 has an equivalent of 1.96 yata, kung tama tayo, no? Can you still remember that when we converted the z value to p-value is equivalent to 1.96. So that in your test, any value, if your calculated value is more than, so anywhere, papunta doon, more than your critical value, what will happen to your null?
Reject.
Reject.
Reject. If your calculated value is less than the critical value, so somewhere here, what will happen to your null?
Accept.
Accept. Okay. So I want to show you this. As your p-value decreases, at 0.05, 0.01, 0.0001, 0.00001, 0.00001, 0.00000 infinite. So habang lumiliit yung p-value mo, that means you are going further and further away from your margin. So as your p-value decreases, this means there is higher or more and more evidence of rejecting your null hypothesis. Tama? Okay. While your calculated value, as you go away here, so that is 1.9, then it becomes 2, 3, 4, 5, 6, 7. So as your calculated value increases, it means you are going further and further away from the margin, right? So this also means there will be more and more evidence that you're going to
Reject the null.
reject your null hypothesis. Look, decrease, increase. So don't be mistaken with that. Huh? So as you decrease your P, the more you're going to reject your null. As you increase your calculated value, the more you're going to reject your null. Parang opposite sila. So when you make a decision, huwag kayong malito, ha? Pag P, habang lumiliit, lumalayo ka. Pag calculated value, habang lumalaki, lumalayo ka. Or the other way around. Okay? Are we clear on that? So that hindi kayo malito when using
Yes,
your
Doc.
calculated and the p-value. So after making a decision, what's next? We're now ready to
Draw a conclusion.
good. And now draw a conclusion. And your conclusion will be based on your null, whether to reject or to accept. Okay. Being a researcher, okay, what we have in mind, okay, we always want to reject. We want to reject. null hypothesis. No? So, parang pagka kasi ang notion, if you accept your null hypothesis, parang walang pagbabago sa ginawa mo. No? So, you wanted to change if kunyari yung paracetamol na ginagamit natin is 500 milligrams. So, challenge mo baka naman po pwede ang ibang value. Okay? But if it remains the same, so ibig sabihin, walang parang, okay, let's settle for that. So what we want yung researcher is to elicit a significant change para po pwede natin sabihin, kahit naman pala hindi 500 milligram yung gagamitin ko, kahit 300 milligram, they still have the same effect. So the decision will always be running around your null hypothesis. And mostly, we want to reject it as much as possible. Okay. So, but it does not mean na dun punta mo. Okay, to reject always. You are committing, if you want to reject always your null, so what type of error you're committing then? Gusto mong i-reject. You are increasing your alpha. So, this is not good. But anyway, at the back of your mind, being a researcher, we always wanted to have a significant difference para meron ka naman ma-report. Okay. So, being said, any more questions? So that concludes the principles of statistics. Okay, so meaning to say, we will not be so much interested with how you're going to compute for the test statistic, okay, but rather you will be taught or you will learn to interpret and use this statistic in making a decision. Okay? Are we clear on that? And I hope and I suppose that by now you are already in this stage capable of making decisions based on the value of your test statistics. Right? Is that correct? Are my assumptions rejectable or acceptable? Okay, so any question? Well, given this situation, we don't expect everyone to be expert in statistics. No? So that will not happen for this course kasi you don't need the specifics. If you still want to continue, then you can take your epidemiology or being statisticians. But beyond that, okay, at least our objective is your decision-making capacity, that you make your decisions based on numbers. Okay. So I think this will be the ending of the course, and the only lacking thing now is practice. So we will be practicing on how to apply your statistical test. So very good.
Sir, ito po,
These are just
sir,
basics, no? So when you use your Excel, siyempre, we don't expect you to be experts. It takes time and practice for you to be familiarized with the different commands used in Excel. So at least you'll have an idea of the parts and how it will work. Go ahead, Doc Deb.
yes sir. So sir, ito po yung sa Excel tutorials just to make your how to activate data analysis icon in Excel. So first, sir, you would want to open an Excel file. Siguro if you can follow me, kung wala pa po kayong data analysis icon in your Excel, you open your Excel file. So you click this, and then after clicking this, you will see an icon dito sa baba. You have the options. And then with the options, you will click in your lower left, yung add-ins. And then go to the center. Ito po, merong go. You will click go, and then you will pick the analysis toolpath and the analysis toolpath VBA, and then click OK. And then, so yun na po sir, when you look at your icons from your data analysis tools, makikita nyo na po sir yung data analysis icon. Like this po sir. Ito po sir, bali i-click nyo na po yung data. Ito na po yung data analysis as a tool in your Excel. Kung wala pa po kayong ganitong tool under the data icon. Yun po sir.
Okay, yes, because okay. Doc Loen, if it's okay with you, open mo yung video mo para makita din namin ikaw. Habang nagre-report.
Ay, si Doc Alisa pa po yung first Doc.
Okay. Doc Alisa. Yan.
Doc. So I'll begin po with a report on the basic Excel functions. Next slide, please. So, hello. So just an overview. So Excel is a software program produced by Microsoft, allowing us users to capture, display, and manipulate data with the use of formulas or functions using a spreadsheet system. So here is a spreadsheet, also known as an electronic worksheet consisting of cells where we enter and calculate data. So the cells are organized into columns labeled in letters and rows in numbers. So a worksheet is always stored in a workbook, and a workbook can contain many worksheets. Next slide. So here's an example of an Excel spreadsheet, as we always see it. Also, when we use Google Sheets, so with the following labels. So we have here the row header with the row number, the columns labeled in letters. The intersection of the column and rows will make up the identity of the cell, which can also be found here in the bar above. So here's the formula bar where we can see the formula. Here is one sheet. When we click on this, we see another sheet, and a collection of this sheet would make up one workbook. Next slide, please. Next slide. So formulas in Excel begins with an equal sign. So this tells Excel that the succeeding characters will constitute a formula. So without the equal sign, the Excel will treat data as text and the calculation will fail. So important to start the formula with an equal sign. So the formula includes addresses of the cells whose values will be manipulated with appropriate operands. So here we see the following 4 operations. So addition, subtraction, multiplication, division with the following symbols. So after the formula is typed into the cell, the calculation is executed immediately, and the formula itself is visible in the formula bar with the result of the calculation found already in the cell. Next slide, please. So here's an example of how we use formulas in Excel. So we first type the formula with the operand, also with the operator, so equal sign. If we want to multiply the quantity times the rate, we enter the cell identity, so C5, then asterisk B5, then we press the enter sign, we get the amount. So getting the results of the remaining cell, we can use the function wherein we click the from here, and then we hover down to get the results of the remaining cells. Next slide. So as for functions, as compared to formulas, functions in Excel are built-in functions. So they can be faster way of doing mathematical operations than formulas. As with formulas, functions also begins with equal sign and contain a function name, followed by the arguments enclosed within parentheses. So here are some example of some of the basic functions we use in Excel. So instead of using the plus sign, the minus, asterisk, or divide by sign, we can use the following terms, so sum, average, max, mean, and so on and so forth. Next slide, please. So here are other basic formulas we use in Excel. So most commonly equal sign, then sum, followed by um, the um, the identity of the cell we wish to add, max to get the maximum or the highest number of in a range of values, minimum. Now you can also use now if we want to identify the current date and time. Count if we want to count the number of records in a single column table, and so on and so forth. So next slide, please. So for the measures of central tendency, as we already discussed previously, we make use of the following Excel functions. So equal sign average, followed by the range of data to calculate the mean or the average of a set of numbers. For the median, we type equal sign followed by median and then the range to return the median on a set of numbers. And then for the mode, equal sign mode, that's SNGL and then the range for single modal values or mode dot MULT range to return the most frequently occurring value in a set of numbers. Next slide. So to continue, Dr. Lewin.
Hello, Doc. Good afternoon. So, also have functions that we can use to measure the measures of dispersion or variability. So to start, we also have the function equals stdev.s for calculating the standard deviation based on a sample. We also have var.s, and then we select the range. This calculates the variance based also on a sample. Note that we also have varp function, which is used when calculating population. And if you're use the var.s, same is true for stdev.s. We also have stdev.p for the population. We also have the correlation function. So the syntax would be equal sign correl, and we select uh, two arrays. Sorry. So we have, sorry. You have the correlation function. So its syntax is that equal sign correl, and then we select two arrays. So one array 1 and array 2, and this returns the correlation coefficient between two sets of numbers. So the value of that this returns usually would be -1. So a positive value, correlation, and a negative value would mean that they have a negative correlation, and values close to 0 mean that they have no or weak correlation. We also have the covariance function. So the syntax would be equal sign covariance.s, and then we select two arrays. So this returns the covariance between two sets of numbers, and this also have three categories. So the first would be positive covariance. So this happens when the value returned is a positive value or greater than 0. And you also have negative covariance. This happens when the value returned would be negative or less than 0. And we also have the zero covariance. This means that there is no clear relationship between the two sets of data. We can also use the percentile function using the syntax equal sign percentile that inc, and then we select an array, as you can see here on the example, and comma k. So this returns the kth percentile of values in the range. So the array would be the set of data, and k would be the specific value that you want to choose. So that's the percentile value. The range should be from 0 to 1. So an example here, we see in this box, the selected data would be from E2 to E4, and then the percentile that the user wants to get is at the 0 point percentile, or this means that he wants to get the 30th percentile. So the function returned a value of 1.9. And we can also use the quartile function using the syntax negative equal sign quartile that inc. And then we select an array, and then we specify the quartile that we want to check. So this returns the kth quartile of values in a range. So also we have discussed this would be a value that ranges from 0 to 4. And if you exceed that set limit, the function would return a value stating number sign num error. So you also have the rank function using the syntax equal sign rank.eq. We select the number. The number is the number whose rank you want to find, and we also specify the ref. This is also a required value, and this is just an array of or a range of numbers. And usually when you select this, non-numeric values are ignored. And we can also specify the order, and this is just an optional. We just select a number. So for example, 1. So here in the example, the number that we of is at the cell A2. So that's here, and then the reference would be the set of data from A2 to A6. The order argument is a non-zero value. The list is sorted lowest to highest. In contrast, if you don't specify the number, or you put a 0 sign on the order, it would return it would sort the data from highest to lowest. So in the example, we wanted to find the rank of the value on A2, which is 7. So in this example, sorry, it is not included here, but the rank here would be 1. And we also have the z-test function. So in this specific example, we have the z-test function for a one-tailed test. We can use the syntax z.test, and we specify the array. Again, this is all we specify A2 to A11, and this is just the value to test. And we can also specify the sigma, which is just optional, but this is again the known standard deviation. So if we omit this value, the sample standard deviation would be used. So in the example, we wanted to get the z value of this set of data. So this is the one-tailed probability value of the z-test for the data set above at the hypothesized population mean of 4, which was specified here, returned a value of 0.0906. So that's your z value. We can also do the z-test function for a two-tailed test. We just modify the syntax. So we use the syntax 2 asterisk minimum z-test, specify the array, the x and the sigma, comma 1 minus z-test. So it's the same, it's the same, it's just the same set of values as before, but this time we are testing for a two-tailed test. So the equation is just modified to reflect that two-tailed test. So in this data set, the two-tailed probability of the z-test is returned as 0.1811 for a specified population mean of 4. We can also do the t-test in Excel. So in this case, we use the t.test function. Then again, since we are comparing two sets of data, we should specify the array. So array 1, comma array 2, and then specify the tails, if whether it's two-tailed or one-tailed, and then the type of test, whether it's again, it's an example. You can use whether it's type 1, which is paired, type 2, which means there's a two sample equal variance, and type 3, two sample unequal variance. So this returns a probability associated with the student's t-test. You can also get the confidence level. So using the syntax equal sign confidence dot t, we specify the alpha, the standard deviation, and the size of the population. So this returns the confidence interval for a population mean using a t distribution. So here in the example, we have a significance level of 0.05, a population standard deviation of 10.61, a sample size of 11, and a sample mean of 79.
Nakita ko na yung tanong mo, where you're coming from.
The confidence value is returned as 7.1. Yes, Doc.
Ito pala yung tinatanong mo kanina, yung differences ng critical value ng z-score. Okay. Yes. That's
Yes,
correct.
Doc.
Sometimes may mga ano talaga kumbaga syntax glitches ang ang mga apps natin. But it's okay. Those are
Yes, Doc.
negligible naman.
Okay po, Doc. And so we also can use the growth function. So use the syntax equal sign growth. Specify the value of the known wise values using the least squares method. So this is good if you want to predict, for example, here in this example, we have the yearly revenues. So if, for example, we have a data of revenues from 2008 to 2019, and then we wanted to predict what the revenue would be in the year 2020. So the predicted revenue 1,000. We also have the linear regression function. So we can use the syntax equal sign line nest, and then specify the values of the known y's and the known x's, and then specify the constant and the stats. So this just returns the regression statistics, including the slope and intercept of a data set. So we also have the intercept function using the syntax equal sign intercept, specifying the known x's and then the known y's and then the known x's. So this just returns the y-intercept or the y-axis intersection using the specified values. The x-intercept would be 25. We also have the slope function using the syntax equal sign slope, and then we specify the known y's, comma, the known x's. So this just returns the slope of a regression line if using the known data. And we can also do a chi-square test. So using the chi-square function, using the syntax equal sign CHISQ dot test, and then we specify the observed range, comma, the expected range. So this returns the test for independence in a contingency table. So this specific chi-square test pala is the test for independence. So yun lang po. Thank you po.
Sir, nakamute po kayo.
Ayun. Sorry. Thank you. Sabi ko, thank you, Doc Alisa and Doc Luen. It's ganda ng presentation nila. But sometimes may mga talagang medyo complicated na, no? Like for example, the regression, yung mga slope, intercept. Usually, we are not particular with the intercept. We are more of the slope para makita natin yung regression. But I think those things are nice to know naman. So, but anyway, like for example, yung chi-square, ipapakita din naman yung specific mamaya on how to do the chi-square test. So, any question with the basic use of Excel? So, what I want you to remember is that in Excel, there are syntax or commands that you need to familiarize yourself. So, parang fill in the blanks lang naman ito eh. So, it will still depend on you kung ano yung inputs ninyo, that will be the one which your apps or your Excel will process for you. So, please ask question, no? But then again, itong mga presentation ninyo, I will not ask you whether it was computed properly or not. So we will assume that you have tried your best to compute and give us. Assuming kunyari kayo yung statistician and you will give us the result, and it is for us to make a decision. Okay. So Z-test again, huh? Z-test.
Start na po ko, sir.
Yes, Dr. Gina, please go ahead.
Okay, so good afternoon, classmate. So I will be discussing Z-test. Z-test, clear po ang sound ko?
Yes, very, very clear, Dr. Gina.
Okay. A Z-test, as we reviewed, is a form of inferential statistics, and it uses samples to draw conclusion about population. So we use it when we need to compare group means. It can be used with a one sample or two sample analysis. And one sample analysis is to determine whether a population mean is different from a hypothesized value, and the two sample version to determine whether two population means differ. Ay.
Okay. Maliwanag po. Again, use Z-test to compare.
Okay, so the Z-test applications, it is performed in studies where the sample is larger, more than 30, and the variance is known. And it is also used used to determine if there's a significant difference between the mean of two independent samples. So it can be used to compare the population proportion to an assumed proportion or to determine the difference between the population proportion of two samples. So what's the similarity between a z-test and a t-test? They both assess the mean of one or two groups. They have similar assumptions, and they allow you to draw the same conclusion about population means. The main difference is that z-test require you to know the population standard deviation, while t-test use a sample estimate of the standard deviation. And we use z-test for more than 30 samples, while the t-test is for less than 30. So for the z, we can compute manually using the z-test formula for one sample and the z-test formula for two samples. So our problem for today, your hospital is testing a new marketing campaign about the newly built health and wellness section. You publish the marketing campaign through your website and link to FB, Instagram, and TikTok. Being the head of the marketing arm of your hospital, you want to see if it significantly increases your website engagement. So you want to compare the average time spent on your website before and after the campaign. So for the step one, we gather data. So we have two sets. The first set is before the campaign with a sample size of 30, mean of 3.5 minutes engagement, and the standard deviation of 0.8 minutes. And after the campaign, our data, sample size 30, mean of 4.2 minutes engagement, and the sample standard deviation of 0.7 minutes. So the second step is to define the hypothesis. Our null hypothesis is that the new campaign has no significant effect on website engagement, while our alternative hypothesis is that the new campaign significantly increases website engagement. So for the step 3, we identify the level of significance. It is stated that both samples are normally distributed with a significance level of 0.05, confidence level of 95%, and critical level of rejection 0.05. So first, we calculate the z-test statistics. We can use this formula or a z-test calculator. It's online. And then we calculate for we get the p-value. The p-value we get, since we got already the z-test equivalent, which is negative 3.607. But since we are using the two-tailed, we're not after the increase or decrease in engagement, only if there's a difference. So we get the absolute value. We don't use the negative. So we get the 3.607. And then in the table, so we get on the left side, under the z, we get the first decimal point, so 3.6. And on the top right, we get the second decimal point to get the p-value. So the p-value for 3.607 is 0.0002. So now that we have the p-value of 0.002, we now get the confidence level for the z-value. Based on this table, for 95% confidence, the z-value is 1.96. So plotting it in our graph, 1.96 is less than 3.607. So for the decision rule, since it is observed that 3.607 is greater than 1.96, which is the critical value, it is then concluded that the null hypothesis is rejected. While if we use the p-value approach, p-value is 0.0002, and since it is less than 0.05, which is the critical level of significance for 95% confidence level, it is concluded that the null hypothesis is rejected. So for the conclusion, it is concluded that the null hypothesis is rejected. Therefore, there is enough evidence to claim that the new campaign significantly changed the website engagement at a 95% confidence level. That's it po.
Very good. Very, 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 very clear. Oh, any question for Doc Gina? That is Z-test. Any question? Doc Gina, pwedeng pakibalik mo muna
Ay.
doon sa,
Yes.
doon sa my graph, yung may distribution curve. Okay. So any question po? Doc Luen? Doc Mark?
Hello po, Doc. Yes, Doc, I have a question po with regards sa Z-table po, Doc. Since the Z value that we computed is 3.607, I'm just wondering po, Doc, whether it's better for us to round up or round down po with regards dun sa sa value ng Z po. And po kaya anong
Yes.
rationale po?
Up to 4 decimal point usually. Kasi minsan sa statistical test yung may makikita kayo na H or T. Ganun. Ibig sabihin, yun yung number ng zero. Hindi na kayang isulat ni computer yung kunyari 10 or 10 or 15 na zeros, di ba? 0.000000. Minsan hindi na niya ano. So I guess you can settle for up to 4 decimal point with regards to your empiric table.
Yes, Doc, pero I mean sa Z-table po kasi 'di ba like ano lang dalawang
Up to
decimal points lang po.
point.
Yes, Doc.
Yung
although
table
yung
mo, yeah. 2 decimal point.
yes, Doc. Although yung value is the same naman.
The same sila, Doc. Kahit
round
i-round
up
up.
or
Lang ng difference
down
niya.
po.
Doc Gina,
Yes, sir.
please comment. Well, sagutin mo si Doc Mike.
Sir, usually they would recommend that you round up to 4 decimal point kasi significant yung first 2 decimal places. So hindi sila nagpapa-round off near the decimal point, the second decimal places. Although yun nga magkalapit naman sila, small and difference.
If you want to make a more precise margin, okay, or the critical value, you can go up to 4 digits. But with regards to the Z-score usually hanggang 2 digits lang yan. Any more question? Doc Mark, did we answer your question?
Okay po, Doc. Thank you po, Doc.
Okay. Any more question before we let go of Doc Gina? Tanong na. Okay, so it seems that 94, the critical value equivalent to 95% is constant. Diba? Makikita niyo 1.96. So you don't need to compute for that if you want to memorize. What you have to compute for is the Z-score of your test. That is more important. Doc Gina, can you go one slide ahead?
This one, sir?
Yes. I think since observed that Z isn't that supposed to be negative 3.607?
Oo, sir. Kaya lang two-tailed po yung tanong ni alternate hypothesis only if there's a change, hindi yung decrease or increase. So parang pag two-tailed siya, you get the absolute value na lang.
Okay, very good. Okay, any more question with the C-test? Madali lang yung C-test, di ba? And ito yung talagang pinaka-bugbog na ginagamit natin kasi mostly we just want to compare results. So it's either you use the Z or the T-test. Ang problems nyo lang dito is, remember, the Z-test has 3 variants, no? The one sample, the dependent, and the independent. Okay, so it will depend if you are comparing a sample towards the population, then you use the one sample. If you are comparing sample within sample, you're going to use the
Two sample.
the paired. And if you are comparing one group to another group that does not have any similarities, then you use the third one, the independent. Okay? So, yun lang naman ang pagbabago niyan. But anyway, ganun pa rin naman yung principle. You just have to take note kung ano yung objective mo talaga, kung anong gusto mong makita. Okay. If no more question, can we proceed to the next parametric test?
Hello, Doc. Doc, sorry po. I have a question po, Doc.
Doc Mark, okay, please go ahead.
Doc, hindi ba one-tailed yung yung natin, alternative hypothesis? The new campaign significantly increased website engagement.
Oo, sir, yung question one-tailed, pero kasi yung para not equal lang yung ano natin yung pinaka-symbol, not equal lang. Hindi niya tinanong yung increase or
Actually,
decrease.
this should be one-tailed. No?
Should be
Negative
one-tailed.
tayo Kaya negative, nandun tayo sa yung negative 3 negative, di ba? So we're leaning to
Sir.
each one as a lesser engagement. But since your what was your hypothesis?
Ito kasi, sir, yung nasa problem natin. Ay, sorry.
Yung hypothesis natin is the new campaign significantly increased the website engagement. Okay.
Sir.
Malinaw naman dito. So, kaya lang ginamit ni Doc kasi is, yan. So, yan kung, ito naman, it is well explained, tail to your left. So,
Kahit naman, kahit one-tailed, more pa rin siya than the Z
so
value.
negative 3 is less than 1.
Less than
So, it's
1.96.
still out of the rejection region. Okay, any more question po? Again, you cannot perfect this at a single sitting, in one sitting. So you need to practice and practice. And the technique here is, if ever you find difficulties or it seems to be more complicated, it will be nice to sit down with your statistician and discuss. Okay, since alam mo na yung mga pasikot-sikot ng statistics, it is good if you can sit down with your statistician. Kasi yung statistician will not dictate you talaga kung ano yung gagawin niya sa data. Tatanungin at tatanungin pa rin kayo, ano po ba yung gusto niyong mangyari? No? Hindi siya yung magsasabi kung ano ang mangyayari. No? So that's the good thing. If you are familiar with all these statistical tests, then you can plan better for the better approach.
Good evening. I will be reporting one of the statistical tests under the parametric test, which is the Z-test. So for our case, there is a new marketing campaign that will be tested, and we want to see if it is significantly increases our website engagement. And so we want to compare the average time spent on the website before and after the campaign. The following data were given for the sample 1 before the campaign. Sample size is 30, sample mean is 3.5 minutes, sample standard deviation is 0.8 minutes, and for the sample 2, which is after the campaign, sample size is 30, sample mean is 4.2 minutes, sample standard deviation is 0.7 minutes. Both samples are normally distributed with significance level of 0.05 and confidence level of 95%. There are steps that we follow to know what statistical test that we need to use. First is to organize the data, in which we need to know the type of the distribution. In our data, the mean and the standard deviation is given, so it falls on the normal distribution. Next is the type of data. We are given time, which is an interval data. We are given 2 samples, to compare the average time spent on the website before and after the campaign. So for the second step, we state the hypothesis. For the null hypothesis, the new campaign has no significant effect on the website engagement. And the alternative hypothesis, the new campaign significantly increased website engagement. So in this case, a one-tailed test is appropriate because the alternative hypothesis is stating that the new campaign significantly increased website engagement, or the mean of first sample is less than the mean of the second sample. We are interested in specific direction, less than. So then we'll use the left tail of the standard normal deviation. For the third step, we will state the confidence level. In our data, we're given the confidence level of 95%, which is an empirical value with a 2 standard deviation. And the significance level or alpha or p-value of 0.05. So here is the confidence level, 95%, and the p-value of 0.05. So next, or the fourth step, is to determine the critical region of rejection or critical value. So this line, or it indicates the margin of error or margin of rejection. This one po. Represented by p-value or critical value. So it marks the boundaries of decision. So inside this boundary is the 95% confidence level. So any sample that falls outside the margin of error or margin of rejection, we reject the null hypothesis. While any value that falls within the margin of error or margin of rejection, we accept the null hypothesis. So for the next step, with the given data, we have met the criteria for the z-test. It is under normal distribution. We are comparing two means. Population variance or standard deviation is known, and more than 30 there are more than 30 samples. So next is we find the p-value of our sample. With this given formula, under paired z-test, where z is equals to sample mean 1 minus sample mean 2 over square root of standard deviation 1 squared over sample size 1 plus standard deviation 2 squared over sample 2 size. So we arrive at the z-score of negative 3.61. So next is, with this, the z-value falls here, negative 3.61. So here, the critical z-value for the one-tailed test at 5 significance level left tail is approximately negative 1.645, which is found in a standard normal distribution table. So empirical value din siya. So if this calculated z-value is less than the critical z-value, which is less than negative 1.645, we reject the null hypothesis. So it's outside the critical value. So with this, we can conclude that there is evidence to suggest that the new marketing campaign significantly increased website engagement. Thank you.
Okay. Yeah, you can start. You can start. So, maganda na yung slide niyo, Doc.
I'm going to report on t-test. T-test is a statistical test that can be used when comparing the means of two groups. It is also a type of parametric test of difference. Thus, it shared the same assumptions with other parametric tests that your data are independent and also are normally approximately distributed and have homogeneity of variance or have similar amount of variance with each group. So it is used in hypothesis testing to ascertain whether two groups differ from one another or whether a procedure or intervention actually affects the population of interest. It is also used when you want to compare the means of a small random sample, which is less than 30, which you got from a statistical population when you want to compare it to another value. So there are two things to consider when choosing the type of t-test to use, whether the groups being compared come from a single population or two different population, whether you want to test the difference in a specific direction. So there are three types of t-test. The first one is the one sample t-test. This investigates whether there is a difference between one group and a standard value. So for example, you want to measure if the mean heart rate of a group is equal to 70 or not. Another type is the independent sample t-test. It probes whether there is a difference between two groups from two different populations. This is also known as a two-sample t-test. This is between subjects design. So example is when you are comparing people from different cities. Another type of t-test is the paired sample t-test. It probes whether there is a difference within a group between 2 points in time. So this is the same group but different time. The different times so tested sila at a different time, like when you make an intervention. So this is also called dependent sample test. This is within subjects design. So example is when you measure the grades before and after an intense review. So in a glance, yes po daw.
Yes, yes. I agree. Ganda.
So in a glance, pwede natin makita dito the differences. So one sample test, the two sample test, and the paired t-test. They are synonymous with for the one sample test is the student t-test. For the two sample test, it is independent or equal variances, pooled and equal. And for the paired t-test, you can also call it as paired group dependent. For the number of variables, one for the one sample test, two for the two sample test, and the paired t-test are two variables. So for the type of variable, one sample t-test has continuous measurement. For the two sample, continuous measurement also categorical or nominal to define the groups. And for the paired t-test, you have continuous variable measurement, categorical or nominal to define pairing within a group. So, for example, here, as I said earlier, for the one sample test, you want to test if the mean heart rate of a group of people is equal to like 60 or not. For the two sample test, you want to test if the mean heart rate for two groups of people are the same or not. For the paired t-test, you want to test if the mean difference in heart rate for a group of people before and after exercise is 0 or not. So, okay, so estimate of the for the one sample test is the sample average, the two sample average for each group. For the paired t-test, sample average of the differences in paired measurements. So for the population, for the sample t-test, it can be unknown. You use sample standard deviation. For the two sample t-test, it can be also unknown. You just use sample standard deviation for each group. For the paired t-test, it can be unknown. you use sample standard deviation of differences in paired measurement. For the degrees of freedom, for the one sample t-test, it's the number of observation sample minus 1. So n minus 1. For the two sample t-test, the sum of observation in each sample minus 2. So n1 plus n2 minus 2. For the paired t-test, the number of paired observation in sample minus 1. So n minus 1. Okay. So if you can use one-tailed or two-tailed t-test. So for the one-tailed t-test, you just want to know whether one population mean is greater than or less than the other. For the two-tailed t-test, if you only want to know whether the two populations are different from one another. So, for example, in this two-tailed t-test, you want to test whether petal length differs by species. So you use two sample t-tests, two different groups of species, and two-tailed t-tests to test only if there is difference. So the three types of t-test first has three types of formulas. The t-test estimates the true difference between two group means using the ratio of the difference in group means over the full standard error of both groups. So ito yung isang formula where t is the p-value, x and x2 are the means of the two groups, s is the full standard error of the two groups, and n1 and n2 are the number of observation. So ito yung two sample t-test formula. And this one is the paired sample t-test formula. So yung example ko po dito, ito yung ginamit ko. So example of a problem, a pharmacy wants to improve its sales. So the previous sales data indicated that the average sale of 25 pharmacies was 50 per transaction. After given training on sales, the recent data showed an average sale of 80 per transaction. If the standard deviation is 30, find the t-score to see if the training provided has improved the sales. So for the stepwise method, first is your organized data. So for the sample, it's 25. And the average sales of each pharmacist before the training is 50 USP. And the average sales after the training is 80. So the standard deviation is 30, estimated at 30. So number 2, to state the hypothesis. For the null hypothesis, there is no significant difference between the sales before and after training. And for the alternate hypothesis, there is a significant difference between the sales before and after the training. So number 3, for the level of confidence, you set the alpha value, so at 0.05. And then the degrees of freedom, since we have a 25 sample, 25 minus 1, that will be 24 for the degrees of freedom. And then we determine the critical value, which is at 1.711. So here's the table. So dito tayo sa 24, and then dito tayo sa 0.05 here. Okay, so kasi one page lang tayo. For the statistical test, the sample t-test formula is this one. P equals to the difference between the mean of the mean sales after training and the training before training. So divided by the standard deviation, which is also divided by the square of 25. So substituting the values, we get t equals 80 or minus 50 over 30 divided by the square root of 25. So we get the calculated value of 5. So at alpha of 0.05, the degrees of freedom 24, and
critical value of 1.711, we proceed to our decision rule that if the calculated value is higher than the critical value, then we reject the null hypothesis and accept an alternate hypothesis. So the conclusion, therefore, looking at the T table, we find the calculated value 5 is more than 1.711. Therefore, the null hypothesis is not true. Thus, we conclude that the training boosted the sales. Thank you.
Yes. Okay, so what you're seeing now is from Doc Deb. She will be reporting about the use of t-test.
Yes, good evening, everyone. I will be reporting about another parametric test, which is the t-test. So just for a little review, it is a statistical tool used when the mean of two groups are being compared, and the salient features of the data or the criteria that needed to be noted in order to use the test is when we compare two means, when there is normal distribution, the population variance or standard deviations known, and the samples is less than 30. So the t-test, so when are we supposed to use a one-tailed or two-tailed test? So we use the one-tailed test if we wanted to determine if there is a significant difference between two groups in a specific direction or in one direction only. So with using that test, the alternative hypothesis, we will want to find out if the values of the means are equal or greater than. And for the two-tailed test, we use this to determine if there is a significant difference between two groups. And for the alternate hypothesis, we only wanted to check if there is a significant difference between the two. So in the null hypothesis, we always want to assume that the means of the two groups are equal. So for the steps in the presentation of the t-test, first, we should organize data. We state our hypotheses, the null and the alternative hypotheses. We determine the level of significance or the confidence level. Also the alpha or the p-value. We determine the critical region of rejection or the critical value. Fifth is we calculate for the p-value, as in this case. And then we make a decision rule and we draw a conclusion. So for the given, so we will imagine a scenario where you are the head of a dietary section and outsourcing the supplies for authorized feeding for patients. And the previous supplier increased the prices of their supply, which left you no choice to get the supply from a new supplier. So we wanted to know if there is a significant difference in protein content of the new group of authorized feedings, because if we wanted to purchase it because it's a lot cheaper. So that's the premise. So for the data, from the previous supplier, which is sample 1, the sample size for both is actually 20. So there's a difference between sample 1 and sample 2 in the mean caffeine content, which is 95 for group 1 and 90 for group 2. And the standard deviations between the two groups is 8 milligrams and 7 milligrams respectively for group 1 and 2. The given confidence level for this is 95%, and it is normally distributed data. So for the second step, we will state our hypothesis as this. The protein content of the OF packs from the new supplier is the same as symbolized by these symbols. The mean of first group is the same as the mean in the second group. And for the alternative hypothesis, we wanted to find out if the first and if there is a significant difference between the protein content of the two groups.
Dr.
Apo.
Deb,
Yes
I
po.
just would like to revise, to correct. In
Po.
your given data, it is stated as caffeine. That should be protein. Okay?
Ay, sorry po po, protein. Yes, protein. Sorry po.
Sorry. Baka hanapin
Okay.
sa'yo yung caffeine mamaya, protein yung hinahanap mo.
Sir,
So
sorry
I
po,
don't
hindi
know if
po.
I was the one who mistakenly put that the caffeine there.
Yes, sir. Oh,
That should be
sorry,
protein.
sir. Copy-paste ko po.
So
Yes, sir. Yes, sir.
we're talking about protein level, not the
Sorry po.
caffeine
Yes.
level.
Yes po. Protein content. I'm so sorry po, sir. So, in formulating the hypothesis, when formulating the null hypothesis, we assume that the two means are equal. And when formulating the alternative hypothesis, we assume that the means are not equal. So I think I already mentioned this one. It's protein content, not caffeine content. Yes, sir. Okay, so for the next step, we will compute for the level of significance or the alpha level. So just to remind us that usually the confidence level is given, which is around 95%. As sir mentioned, it should be around the middle. So usually it is already stated in a study, and it can actually be adjusted, increased or decreased in order to lessen or decrease the error. The alpha level or the p-value states that the smaller the alpha value, the higher the confidence level, the more acceptable or reliable the result of the study is, or increasing the chance that the result of the study is reliable.
Yes.
So the third step will be to get the level of significance. So given that the confidence level is 95%, we will get the alpha level or the p-value. So how to get it? Using the two-tailed test. So one is actually yun yung 100%, and then we make it, pag ginawa lang natin, we move the decimal point to make it a whole number, minus the 0.95 or the 95%, which is 0.05%. Since we're using the two tails, so we will divide that by 2, and the alpha value will come out to be 0.025. We will get the degrees of freedom. We use the formula for computing two groups, because we have two groups where the n is the mean of the group. So since there are two groups, this will be the formula. Degrees of freedom is equivalent to the mean of 1 plus the mean of 2 minus 2. So the degrees of freedom will be 38. So when we look it up, okay. So we look it up in the table, in the T table. So how do we look it up? So ito yung degrees of freedom. So we will find 38. And then from the column where 0.025 p-value appears, you will get the point where they meet or they transect. So the critical value as noted from the T table is 2.024. Okay. And then the next step will be to calculate the p-value using the formula. Sorry, this should be protein. Okay, so this, yes, sir. So this, so this is how we compute for the value of the calculated p-value for this. And the calculated p-value is 2.1. So as mentioned earlier, in a diagrammatic representation of acceptance or rejection of our, or making the decision rule, the critical value appears somewhere on this area for both tails, because this is a two-tailed test for both tails, and the calculated value is 2.1. So if the computed p-value or the calculated value is greater than the t-value, we reject the null hypothesis. Hence, we draw up in a conclusion that just a conclusion that there is a significant difference between the two groups, or there is the mean or the average of the two groups, or the averages of the protein contents of the two groups is significantly different. Thank you.
Okay, very good. So,
Tapos sir,
baka
yes,
limutan.
sir, meron lang po akong kasi tinry sa Excel, nagpaturo din po ako.
Yes, very good, very good. So that you can show both the best of both worlds.
Yes, sir. Sir, yung dito po sa Excel, if we are going to use this, yung ating sample, sir, parang we just made the dummy
Okay.
tawag ito,
Yes.
data for groups 1 and 2. And then using Excel, we will be able to calculate already. So although sir, from the tawag dito, the result, medyo malapit lang po siya kasi po it's just a dummy table.
Yes.
So,
It's okay.
ang gagawin nyo lang po, sir, is punta po kayo you go to data, and then the data analysis.
Okay.
And then, we go to sample with unequal variances, and then press OK. And then we click on the variable range 1, and then we click on the data for group A. So nag-appear na po siya doon. And then we click variable 2 range, and then we click on the second data. Yan po. And then we click the labels. Click on the labels kasi may label po siya doon. And then we click on the output range. We click this. Tama ba? We click this, and then we just click on a cell para po lumabas yung result niya. So ito na po yung result niya ulit. So ganun lang po siya kapag Excel. So mas
Yung
mabilis po.
output trains will be where you want to place your summary. Yun lang yan.
Yes, sir.
And
Opo.
be careful lang with the commands. Usually, if you click on the labels, make sure that you also click on the labels kasi hindi
Yes, sir.
kasama yun sa computation. No? So again,
Yes po.
yeah, so that will be the summary. T-test summary. Bakit ginamit? Kasi meron ding prompt doon, di ba? Sabi, you have to select what type of t-test that you're going to use. So you selected two sample t-test, right?
Yes, sir. Opo.
Marami kang pagpipilian kasi doon. Just be careful. Anyway, alam niyo naman kung anong klaseng data meron kayo. So it should be appropriate also what type of t-test you're going to use. Kasi we have three types of t-test, diba? The one sample, the paired, and the unpaired. Yan.
So, yan. Explain ko lang, Doc. Abot ng makakaya, Doc. Okay, I'll try to explain the best way I understand it also, Doc. So, yan. For the t-test, I mentioned a while ago that it's the most simple inferential statistics, and then it's used to assess whether there's a significant difference between the means of two groups. So ayon, specifically we have three under the t-test: the one sample t-test, the paired t-test, and the unpaired t-test. So for the one sample t-test, in this table, I differentiated the three. Okay, so for the one sample t-test, this test is used to compare a sample mean to a known population or to a specific group already. Meaning to say we have one group against the set of mean. So with regards to the number of samples, we only have one sample here. So one group comparing it to a mean. Okay, so for the paired t-test, or the what we call the dependent sample t-test, it compares the mean of two related group which are matched pairs. So for the number of samples also, we have two samples here, and most these samples are actually dependent or related from each other. So basically, this is testing the same mean twice. So yung mga before and after na may ano. So same lang siya na sample, then before and after. So this is the type of test that we use, the dependent or the paired t-test. Since both samples are related to each other, but then different groups. Okay, for the last type of t-test is this unpaired t-test or the independent. So with this, ano naman po, it used to compare the means of two independent group. So there are two totally different or independent groups. So two groups not related to each other, just like the paired t-test. So with regards to the assumption of independence, we cannot apply this with the one sample t-test. And with regards to the pair t-test, we have, ayun, as what mentioned a while ago, each group or samples are dependent from each other. We unlike the unpaired or the independent, of which the samples are not related to each other. So yeah, so I hope I made that clear. In this slide, actually in this table, I just tried to differentiate the three types of three tests first. So before going to the samples of each. So going now to yes po. So going now briefly lang po to the
In your Excel, it is very important for you to determine what type of test you're going to do. Kasi merong prompt doon, you have to select if it is one sample t-test, paired and unpaired. So this is very important.
Yes, Doc. Opo. So again, so just a summary, again, yung one sample t-test, we have one group only and we test it with a set mean. Yung unpaired naman, group 1 or versus group 1 or group 2 versus group 2 or group 1 versus group 2, parang ganon. And then yung paired t-test naman, the means of group 1 and 2 compared to the groups, another group na naman, and then you have the mean average of those two groups. So anyway, medyo complicated po yung pag-summarize na yon. So that's why I went, Doc, to give one sample per specific t-test.
Yes.
So let's go to the next slide. Okay, so first is the one sample t-test. This is what I said a while ago, na yung we only have one group that we need to test against a set of mean. So one group lang yung samples here is we only have one sample. So mas easier siya compared sa dalawa. So example here, we have a researcher reports that the average salary of the college dean is more than 63,000. A sample of 35 college dean has a mean salary of 65,700. So given a significant level of 0.05, so the test claims that the college deans earn more than 63,000 a month. So it was also said here, given then that the standard deviation of the population is 5,250. So again, just like what Devs did a while ago, we need to deal with every example or every test given to us step by step. So first is still to test the normality of the data. Next slide, please. Jigs, next slide. Okay, ayon. And then we need to define the null and the alternative hypothesis also. So we have the given values already. Okay, then state the null and the alternative hypothesis. The null here is that the mean average is less than 63. And then the alternative hypothesis is the mean is greater than 63. So we are actually having the one-tailed test here also. So for step 2, we also, just like other tests reported a while ago, we need to get the significant level. So for this particular study, we also use 0.05. And then same lang din po, we need to get the degree of freedom also. So before going to step number 3, sorry, I failed to mention, we need to get the degree of freedom. So I guess it was clearly reported also and explained by Doc Tim that the degree of freedom is the sample population minus 1. Di ba po? So for here, since we have the sample of 35, so 35 minus 1 is 34. So and then with the use then of the t-table, although I'm very sorry also, Doc, hindi po talaga ako techie, I failed to insert the table na ginamit ko. Basta here, we have the degree or the level of significance na 0.05 and we have the degree of freedom 30. With that given values, we were able to compute from using the t-table. We had that value, the critical value of plus 1.645. And then with that, we were able to use this formula na po. Yan. And then the computed na now, the computed z value is 3.043. So next slide. With using this computed 043, so again, going to the, ayan. So yeah, we need to decide if we are going to accept or to reject the null hypothesis. So same sa mga step-by-step discussion made a while ago, since the level of 3.043, the computed value is more than that of the critical na 1.645, which we got from the table, then we need to reject the null hypothesis. So we need to accept the alternative hypothesis mentioned a while ago, that the mean salary of the deans is more than 63,000 po. So next slide, Jegs, please. Yan. So that's the conclusion. So since our computed is more than that of our critical value, then it's enough evidence to support that the claim that the monthly salary of the college dean is more than 63,000. So we rejected the null hypothesis and accepted the alternative hypothesis. So that's it for the one sample t-test. So klaro lang doon, yun lang po. We have one sample, which is yung salary lang po ng dean. So we didn't compare it to other samples, and we just compared one group versus the mean. Okay. And yung second po na t-test, okay, let's go to the next specific type of t-test, the paired t-test. Okay, for this paired t-test, Doc, ako lumabas ho ba saan? Ayan. Ayan, okay. We have a table there. So, yes po. For the paired t-test naman, it's a test that usually we usually use when we need to test the mean, okay, twice. So yun yung mga before and after na study usually na ginagamit natin. So for example, reading this specific type of example given. Doc, so sorry po, I hope okay ho yung mga examples ho na napili ko, Doc, pero please correct me or stop me if may kulang, Doc. Apo. Example for this, a random sample of 8 patients were selected and their blood pressure were measured before a need. Okay,
Yun lang. Napuputol ka, Doc. Yes.
Here, we need to test the hypothesis that the mean of the patient's blood pressure is lower after use. Ay, Doc.
Yeah, napuputol kanina. I don't know if it's all about me. Napuputol din ba sa inyo?
Hello, Doc.
Yeah. Nawawala yata, Doc, yung napuputol yung...
Sorry, Doc. Yan, Doc.
Yeah, okay. So, please go ahead.
I am heard na po now, Doc.
Yan, okay na. Sige.
Mas clear na po siya.
Yes.
Okay, so now here, yes po, sorry, Doc. Going back to the paired t-test, again, this tests used to test the same mean twice. Yun po yung sinabi ko kanina. So 2 groups, okay, of which the samples are actually related to each other. Okay, so again, given this particular example, a random sample of 8 patients were selected, and their blood pressures were measured before and after treatment with a new drug in controlling the blood pressure. So we need to test the hypothesis that the mean of the patient's blood pressure is lower after taking the drug using a significance level of 0.05. So as you can see, we're just comparing the blood pressure, same lang siya, pero may before and after. So unlike yung kanina, yung sa single one sample test, now we only have one group comparing it to the mean. So here may before and after siya. So we need to if ganun yung test, then we choose the paired t-test. So as we look to the looking back into the table, now we have 3 rows and then 9 columns. As you can see, we have 8 since we are using 8 patients. So we have 8 subjects here. And then you have the before and after. So before, the systolic blood pressure taken among the 8 samples before taking the medications. And then yung after naman, the third row is their systolic blood pressure after taking the blood pressure. Okay. So I'll proceed to the next, Doc. Okay, clear po yun.
Okay. You're using one sample.
Okay,
Same
so for the
sample.
yes po. Yes, Doc. So with regards to the pair t-test, we need to take note that there are certain conditions also, just like what I've mentioned. So here we have a paired data since we're taking measurements before and after the drug. But then we use one sample pero may before and after using that same sample. And then each result are independent from each other. Okay. And then we had random samples. And then we assume that the difference in the blood pressures is normally distributed. So kailangan yung distribution niya normal din. Okay. For the next slide, please. So same thing kanina. So we always go back to the steps para hindi mawala. So the first things first is to graph the difference data using a histogram to confirm that they are really normally distributed. Kasi if not, then we forget about the paired t-test. Okay, they should be normally distributed first. And then if we are assured with the use of the histogram that they are normally distributed, then we proceed now with the second step, with of which we need to form the hypothesis na. So here we have the null and the alternative hypothesis also. Okay, for the null hypothesis, sorry na shortcut yung slide, but for the null hypothesis of this particular study, there is no significant difference between the blood pressures of before and after taking the drug. And for the alternative hypothesis naman, there is a significant difference between the blood pressures before and after taking the drug. So again, take note also, we need to set the value of the alpha. So katulad din ng mga tests kanina, of which for here we have 0.05 and we have also the degree of freedom. So again, diba, it's the sample minus 1. So here we had 8 samples minus 1. So the degree of freedom of this particular test is 7. And then we also need to take note of the standard deviation and the mean. So for the particular study, we have the mean of 4.5 and the SD of 6.9. So na-compute na po yun using yung yung may app po na yung tinuro po ninyo, Doc. Okay, so and applying with
descriptive stat, diba? You can always elicit the standard deviation using the descriptive statistics.
Yes, Doc. Okay. Then after that, so the fifth step is the same lang din. Pabalik-balik lang po yung paggamit ng t-table natin. So with the degree of freedom kasi and the level of significance na 0.05, given na po yung critical value. That's why we were able to get and then compute it using the one that you see now, yung ating formula. Then we were able to get the value of 1.843. Okay, so next slide. So yung 1.843 is yon greater than the 0.05 that we set. So since the p-value is greater than 0.05, where our conclusion comes in, wherein we need to reject the null hypothesis. So therefore, we need to accept the alternative hypothesis and to come up with a conclusion that there is an evidence to conclude that there's really a difference between the blood pressures of patients before and after taking the drug. Okay, so that's it for the paired. So for the last na po yung unpaired. Okay. Yung unpaired naman, medyo mas complicated, mas nahirapan po ako intindihin. Pero Anyway, Doc, you can always stop me pag may mali or if you want to add something, Doc.
Yeah,
So,
it's okay.
here naman is
Yung una kasi, group 2 and mean, it's just like comparing a sample to a population. So yung second kanina, yung paired
yes,
test is kayo-kayo mismo, using same sample at a different time. Okay, so ibang result.
yes,
For the unpaired naman, you use two groups that are not similar to each other. So yun lang, ganun lang kasimple. Unpaired sample.
yes, Doc. And then lastly, Doc, yung unpaired t-test na po. So for the unpaired t-test, this is comparing two independent variables na. So, yung kanina, same lang, 'di ba? Before and after the blood pressure, same lang yung mga tawag nun, subjects. We just have, and both are related. Yes, Doc, may before and after lang na samples from the same subject. Here naman, it's totally different. So, example, for us to be able to understand it better, we want to test whether a medicine is more effective in reducing blood pressure than the current one. So we do an experiment on some patients with group 1 using the current state of the act or the innovator drug. And then the second group is treated with the novel drug or the new drug in the market. So if nakikita nyo, two different drugs talaga ang gusto nating i-test. So totally different siya. And those are independent from each other. So that's why if ganon, then we use the unpaired t-test. Okay. So again, going back, we still, para hindi mawala, let's follow the steps so that we can come up with a more systematic way of coming up with a conclusion. So again, go back to forming the confirming pa rin, to confirm, Doc, using a histogram, and we need to make sure that they are normally distributed. So yun talaga ang first. And then if we are assured that they are normally distributed, then we proceed with the forming of the hypothesis. So for the hypothesis, the null hypothesis here is there is no difference between the two groups of patients taking innovator drug and the new drug. Okay. Then for the alternative hypothesis, that there is a significant difference between the two groups taking the innovator drug and the new drug in the market with regards to the effect on their blood pressures. Okay. So the next slide, please. So same lang, third step, we need to set again the significance level, of which we always set it at 0.05. And then we also need to get the degree of freedom samples. So, ayun. Yung outcome po nito after the study, you can see. So, using the group 1, yung X1 po, those using the innovator drug. And yung X2 naman, yung 13, those who are were tested with the market. So, after getting that, the next na naman po is to get also yung table of difference at level of 0.0, that 4.83 for the first group and 8.23 for the second group. And then apply lang po yung mga formula din, which is given naman po through the doc team. There are applications
Sayang, nawala. Okay,
sorry.
you're following? Yan.
Yeah. So, ayun, upon application of the formula, Doc, we were able to come up with a calculated t-value of 1.7. So, i-cut short ko na lang po, Doc. So, same lang naman, but given the formula, then actually, since there's an application for this, we were able to come up with 1.714. So, this is greater than 0.05. of which with this we conclude that we can reject the null hypothesis, meaning to say accept the alternative hypothesis, which states that there is really a significant difference between the two groups taking the innovator drug and that given by the given of the tested with the new drug to control the blood pressure, doc. I think that's the last slide po, doc.
Okay.
The floor, and I'm
May,
from Bohol and
may
from Group
student
1.
may student number ka pa talaga, Dr. Ruel, student ID number na. Mukhang proud ka dyan, 24.
Of course, Doc, kasi I will be reporting about ANOVA and chi-square. So to proceed, so analysis ANOVA is shortcut for analysis of variance, and it is a hypothesis test used to compare the means of three populations or three or more populations. A factor in ANOVA describes the cause of the variation in the data. For example, an independent variable, while a level in ANOVA describes the number of categories within the factor of interest. Oops. Saglit lang. Okay. So, for an example of ANOVA is the completely randomized one-way ANOVA. It's the simplest type and involves an independent random selection of observations for each level of one factor. And it tells us that it can tell us that a difference exists, but cannot tell us or allow us to compare populations and determine where the actual difference is. So to proceed with the assignment, you are the training officer of the Department of Surgery in your hospital, and you want to determine if there's a significant difference in the in-service exam of your surgical residence test scores compared to other trainings hospitals, specifically Hospital A, B, and C. So you collected test scores from a random sample of your surgical residents from each hospital. So first step, according to what Dr. Tim advised us, is to organize data. So here is our data, which is basically a summary of your surgical residence test scores in tabulated form. And the next step is to state the null and the alternative hypothesis. Our null hypothesis for this problem is that there is no significant difference in the test scores among the surgical residents from the three schools or hospitals, while the alternative hypothesis will tell us that there is a significant difference in at least one, which means that at least one mean is different. And next step is to state the level of significance. So our alpha is at 0.05. And the next step is to determine the critical value, our critical region of rejection, which is our critical value. So basically, sorry, we have 90 sample size, but we have three different rows. So to get the parang numerator for your degrees of freedom, when you check the uh, F table, F distribution table, you have to get your degrees of freedom. So to get our value for the numerator, we will get -1 from the 3, so it becomes 2. So 2 is our degree of differential for the numerator, while the denominator or the lower portion of the critical table, it's 87. Sorry, Doc Tim, hindi pala to Excel. So,
Okay lang.
parang mano-mano.
Yeah,
So,
napapansin ko nga, gusto niyang mahirapan yung sarili. But this is very good. This is very good because Excel will just be prompt, no? Ito is talagang itinuturo niyo yung process para maintindihan niyo how did you arrive for all those factors. That's good. Okay, that's
okay,
good.
thank you, Doc Tim. To proceed, so, di ba we were we were able to calculate our degrees of freedom for the numerator, which is 2, and then degrees of freedom for the denominator, which is 87. But the problem is that there is no value for the denominator, which specifically states the value for the level at 87. So we have to compute it manually. So how do you compute it? Using the uh,
Galing ni
Uh,
Dr. Well, talagang
by
minano-mano pa
interpolating,
to ah.
sorry Doc, by interpolating the data from the degrees of freedom from the specified number 60 and 120, and to get the actual value at level 87, we will interpolate the data, no? So using the following formula and substituting the values, we can get the value which is actually 3.114. So since we were able to get it now, we can now proceed to the next step of the problem, which is to choose the statistical test and test the test statistics or get the calculated value for the test sample. So we have a lot of formula here, no, just to get the F value where we need to compute for MSB or the mean square between groups, and the means MSW, which is the mean square within groups. So medyo hindi clear here, but ito yung mga formula. To be very specific, to get the mean square between groups, we need to get the value from the summary of squares between groups and the degrees of freedom between groups using this formula. So substituting the values, we will get, and computing it, we will get a value of 190.005. And next, we need to get the MSW. And here is the formula. And if we substitute the data from the given data, we will get the following value, which is 110. So now to calculate our F, or we need to substitute the values using the formula MSB over MSW, which will give us a value of 1.727. Next step is to make a decision, because it stated that if F computed value is greater than the F tabulated value, we have to reject the null hypothesis. But since we got a computed value of 1.727, which is less than 3.114, we do not reject the null hypothesis. So this is just one way of viewing our data, no? Using the values we were able to compute, and we were able to cross-check across the F distribution table. So you can see our answer lies within the do not reject the null hypothesis. So therefore, we can say that there is no significant difference in the test scores among the surgical residents from the 3 hospitals. So we have to accept our null hypothesis.
Very good. That's your last slide, Doc. Dr. Well.
For ANOVA, Doc. Yes, Doc.
Yes, sir. Okay. Galing na. So I commend you, Dr. Well, for the very very profound ba tawag dyan, the discussion. Okay? So again, any question from the group? Isang bagsak nga palang palakpak, baka makalimutan natin. Can you stay on that slide, Dr. Well? Okay? So again, our objective is to compare three sets of variables or three samples, no? So our objective is to find the critical value and the calculated value. So the critical value was 3.114. How did we arrive with that? Well, the very complicated way of computing it, yes. So especially, pinakita ni Doc Roel kanina, minsan may makikita kayo na ganyan na hindi na siya pumapasok doon. But there will still be ways on how to compute that. And very good na ipakita niya kung saan talaga nanggaling yung F value for the critical F value. No? So it is 3.114. And then proceeding with the value of test, calculated sample. So two phases kasi yan, yung MSB and MSW, you have to compute it if you do it in longhand. But eventually, our purpose is to get the value of your F which is the calculated value of your test, which happened to be 1.727. So if we try to plot it, bakit niyo nakikita parang ganyan yung yung table ay yung distribution? So it happens to be abnormally distributed, no? So at least you have to find the critical region of rejection, which is 3.114, and your computed F value is 1.727, which falls within the no rejection region or the acceptance region. So with the degrees of freedom of 2 and degrees of freedom 87, ganun yung pag-report niya with an alpha level of confidence of 0.05 or 95%. The calculated value, computed value, blah, blah, blah. So that's how you make your decision. Okay, very good. Any question with ANOVA? Any question? You can also use your Excel, ha? So, ganun pa rin naman yung the way you will compute it. So, maybe I can give you an example on how to use your Excel when you're computing for ANOVA. I have a file here. I will just send it to you. So any question po for ANOVA? ANOVA? Remember, more than 3, more than 2 samples. Pero pag 2 kasi yung samples, it is more appropriate if you use the Z or the T test depending on your data set. Pag more than 3, you better use your ANOVA. Okay, if no question?
Wala, Doc.
Okay. So, my topic is all about ANOVA testing. So, sample problem. Suppose we are all teachers and we want to know whether or not the 3 different exam preparation program could lead to significant difference on mean score on students on a certain exam. So to test this, we recruit 30 students to participate in the study and split them randomly into 3 groups. As to, let's say, group A, those patients given a reviewer handbook only and then let them study on their own. Group B, given a reviewer handbook and review classes was given. And group C, given a review handbook, review classes, and a pre-test was also given. So that the students was given assigned randomly into 3 groups and given those 3 different types of exam preparation program. Then after 3 weeks, we'll try to see if there's a difference on their mean scores among the group. So they were given or they are given the same exam after 3 weeks. So as to our problem, so is there a significant differences on mean scores of groups of students with a different exam preparation program? So given this information, we have 30 students, 3 different independent variables, and we are expecting a qualitative dependent variable, which is the exam scores. So next is we have to do.
Chris, your exam result is quantitative.
Quantitative.
Sorry. Yes, sir. Stand corrected, sir. What I mean is quantitative. Sorry. Yeah. So.
Okay, because that's
Kasi
what
sa Windows na naguguluhan ako.
ANOVA uses your
quantitative.
Baka ma-confuse lang kayo.
Yes, sir. Sorry. I mean quantitative dependent variable. So next is we have to state our hypothesis. As to our null hypothesis, there is no differences in the mean scores of 3 groups of students using 3 different exam preparation program. Then as to our alternative hypothesis, there is a significant differences in the mean scores of three groups of students using three different exam preparation programs. So next is to state our level of confidence. So maybe we are very confident, so we just give it a 95% or p-value of 0.05%, 0.05 na p-value. So given the data, we have, as to our sample groups, we have 3 variables, and we are testing expecting a quantitative sets of data. So we have to choose our type of tool to test our hypothesis, and because of we have 3 samples given, so the best type of analysis will be used for this is ANOVA. So as to our decision rule, if the calculated F value is greater than the critical value, then we will reject our null hypothesis. But if our calculated is less than the critical value, then we should accept our null hypothesis. Now, so after collecting, so lumabas yung mga test results nila, no? So we will organize it, then put in the Excel. Merong solution talaga dito, pero medyo mahaba. Medyo mahaba. So with the benefit of Excel, we will try to use Excel as to compute our calculated F value. So after gathering the data and organizing in such way, all we have to do is to use the data analysis tool of Excel. So just like data.
If you use the longhand kasi there will be 2 states eh. So
yes, Doc, yung compute mo pa yung mga mean average and all.
Mahaba din yun.
Mahaba masyado, Doc.
We're not after that. We're after the result. You can use your Excel. It's okay. It's forgivable.
I get your words, Doc, na you are not making us to your one. So we will just use this data analysis. So as to input range, all you have to do is you do like this and shade all the data you input and press enter. And then since my first row is labeled, you have to check this label. If you start here, then it's okay. But I also include that. Oh, sorry, mali na yan. Ayan. And then enter, and then check the label since our first row is in the label, and then our level of confidence, our alpha value is, let's say, 0.5. Then as to range, you can put anywhere there. Where do you want to put the analysis? Let's say here, and then enter, and then press OK. So it will just give you the ANOVA table. So as to conclusion, so since our F computed value is 2.3 in the ANOVA table is less than our F critical value in the F distribution table, the same pa rin ito if you go on Handoc, but you have to get the degree of freedom, and then you refer it to the F table. Then we fail to reject the null hypothesis. Therefore, accept the null hypothesis and reject the alternate hypothesis. This means that we don't have sufficient evidence to say that there is a statistically significant difference between the mean exam scores of the three groups. I think that's all.
Okay, very good. So, well explained naman, Doc Chris. Okay, magandang ang extensive naman yung explanation. So, any question? There is other way, the harder way around. If you want your life to be difficult, you can use the long method or the manual method. But the easier way around is you can use your Excel. So again, your Excel, eventually you will elicit this summary. Okay, the summary is the one on your side, ANOVA single factor summary. So the problem lang again with the use of your Excel is marami kang fill upan na blanks, di ba? So you have to identify the variables that the samples or the values that will be included. So garbage in, garbage out. Once na naklik mo yung iba, so iba rin yung magiging result mo. But anyway, at the end of your process, you will be presented with a summary. So the summary is this one. So napakadaming mga numbers dyan. No? So the thing that you need to see or for you to consider is the critical value of F. That is the one that you're going to use in your decision making. So Doc Chris, if you can highlight that F crit with the yellow siguro, you can put, you fill. Go to home. 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 Yeah. Home.
Yun, sorry.
Yeah, lagyan mo ng yellow. Yeah. So ito lang naman ang importante diyan sa summary na yan, no? So this will be your critical F value. Okay? So the decision rule. If the calculated F is greater than the critical value, then you can make a decision. Okay. Beside your F crit, you also have your P value. P value 0.1111. So again, with your confidence level of 0.05, where would a 0.1 lies? Outside or inside? The inside. So again, you are going to accept
Of the null.
okay, the proposition of wala palang kwenta ang study program. So kahit hindi mo sila study program, pare-parehas pa rin yung maging. Okay? So any question with the use of t-test? Ay, ano ba? Dali lang, na. So, yun lang naman talaga palagi ang titignan ninyo. The p-value and the critical value so that you can plot it para mas malinaw at makita ninyo talaga kung where it lies and then eventually you can make a decision. Okay? Bago natin makalimutan, isang bagsak na palakpak kay Doc Chris for a well-presented ano ba? Parang ano lang naman talaga yan, nambablap lang talaga mga statisticians, no? Pagka narinig mo yung ano ba, ganun lang pala ang ano ba. Pero pagka wala kang kaalam-alam, parang ang bigat, no? So nambablap lang mga yan. Madali lang yan, napakadali lang yan. Okay, if no question, let's proceed with the correlation test. So we're chi-square pala, yeah. Sorry, chi-square
Okay, Doc.
test.
Okay, Doc. To proceed, Doc,
Si
we
Doc
use...
Roel pa rin ang kai.
Ako yung naka-assign, Doc, tapos naka-oo na ako, so hindi na ako hindi ko na
Yes.
tinake back. Panindigan ko,
That
Doc
makes
Tim.
you an expert. Expert na
Ay,
expert
hindi
na
po,
si Doc
Doc.
Roel yan. Hindi nyo na yan
Hindi po, Doc Tim.
mapapalitan. Ibitin nyo man siya na ibitin nyo man siya ng patiwarik. Hindi na niya, hindi nyo na matuturuan si Doc Roel. Very good. Sige, it's okay.
Thank you, Doc Roel.
So to proceed po, we use the chi-square test to confirm whether a set of data follows a specific probability distribution, and it can be used to determine whether two variables are statistically independent. So unlike our bell curve, our chi-square distribution is not symmetrical and has a positive skew, meaning as the number of degrees of freedom increases, the shape of the chi-square distribution becomes more symmetrical. So as you can see on the figure on the right, muna siya. So it becomes more symmetrical according as the number of degrees of freedom increases. So why do we care about the chi-square distribution? Because we can use it in many tests, like comparing three or more populations, population proportions, performing hypothesis testing for variance or standard deviation, performing goodness of fit tests, and testing for independence between two categorical values. And like what Doc Tim kanina said, we can use this you can use this test for nominal and ordinal data. So let's proceed with the case. Sample case, you are the head of the city health office of your province, and you are tasked to determine if there's a significant association between smoking habits of the smoker and non-smoker and the occurrence of respiratory illness among a sample of 200 participants from the 10 municipalities of your province. So here is the data, and our alpha level of significance is at 0.05. So step one is to organize data. So we separated or tabulated the data according to what was given, no, regarding the observed smoking habits of the population versus the expected. And we were given a null hypothesis and the alternative hypothesis of no significant association for the null hypothesis and alternative hypothesis stating that there is a significant association between smoking habits and the occurrence of the respiratory illness. And again, our confidence level is at alpha equals to 0.05. So the next step is to determine the critical region of rejection or critical value using our degrees of freedom. So using the chi-square table, you can see here that our degrees of freedom is at 1 at 0.05 level. So we will get a value of 3.841 using the chi-square distribution table. Next is choose the statistical test and the test statistics so that we can get the calculated value of our test sample. Because it's not stated, no, we need to get the data by again extrapolation. Although like if you're able to view the video that Doc Tim presented last night, ang bilis gawin sa Excel. But if you want it to if you want to see how we can do it the longhand or the longer version, this is how you do it. So by computing for the values, we can now put the data for the expected smoking habits of the population. So again, that's the data. And to get our chi-square statistic, here is the formula, which is basically uh, the summation of the square of the difference, getting the difference of the observed and expected values and getting the square of that value divided by the expected and summing up for all the values. So by if we calculate it, replacing the data that we were given, we will get a value of 3.57. So the next step is to make a decision rule. So our value is less than the one in the tabulated portion, so we do not reject the null hypothesis. Although you could possibly, based on the sampled based on the population, apparently there is no significant association between the smoking habits and the occurrence of respiratory illness. So that's all, Dr. Tim.
Yeah. So wala eh. Wala. Yeah, it could have been. I don't know if that would be a matter of error in collection of your data or if that's the truth. All we know is smoking will affect respiratory illness when in fact based on your data, you can say na wala naman palang effect yung smoking. Although these are hypothetical numbers lang to show, no? So yun yung reason kung bakit siguro sinasabi niya dito na I'm not saying na smoking does not cause any respiratory illness. But since these are hypothetical numbers, okay, yun yung nakuha natin. So the conclusion should remain na there is no significant association between smoking and the development of respiratory illness. Okay? Dr. Roel, can you start with the first slide muna? So any question po with the chi-square? Yung ano, yan yung contingency table. Contingency table.
Ay, saglit na po.
Yeah. So the first thing that you have to do is make a contingency table. So yung observed table, contingency table, yun yung nakita mo. So those were the data that will be represented. So what is lacking here is the expected data. Ibig sabihin, ito yung expectations kung mangyayari if we will count the smokers who will develop respiratory illness and not. So later on, we will try to compare this one if they fit together or if the observed is just the same with the expected result so that you can conclude if really smoking will produce an effect on the respiratory illness or the other way around. So you're expected, you have to compute for the values there. Okay, if you use the Excel, there will be prompt that you can use. I can give you another example for this. I will give you a video for that. Ayan pala, meron naman palang ano si Dr.
I tried to do it the way you showed us, Doc.
Yes.
Team. So,
so again, gumawa siya ng contingency table. Maybe you can highlight.
ito rin nakuha na value, Doc Tim.
So yan, this one is on your right. The observe, this is the contingency table. Do you see my cursor? Hindi na. Anyway, yeah, on the right, yan. Siguro lagyan mo ng feeling itong contingency table mo para makita natin.
Bakit observe?
Yeah, expected dapat yan. Expected.
Expected, yes, Doc. Hinahapi lang kasi, Doc Tim.
So now, paano nakuha? Di ba dapat wala itong 24, 56, 36, and 84 in your contingency table for the expected. So you have to compute for this. How will you compute for this 24? You use the chi-square test as your syntax or your command. And so chi-square test would be equivalent to the sum of the rows divided by the sum of the column. Ganon yan. So, Dr. Roel, you can go ahead with, you can explain.
Basically, ito lang, Doc Tim, yung tinuro mo sa amin through the video na i-copy paste lang siya but make a placeholder sa ano, maglagay ng dollar sign para yung
Mabilis na mag-compute for the other box. So you just have to cut it out. And then you just have to, this should be 24, this should not be 15.
Yes, Doc.
Kasi
Ano yan?
24 plus 56 will be 80, 36, and 84. Always take the total kung they are equivalent. Okay?
Yung formula, yung pinapakita niya, Doc Tim, pag hina-highlight siya. Like this, so
yan, nandun yung formula ninyo, no?
Oo.
Kung meron kayong discrepancy, better remove the dollar sign kasi meron tayong syntax error pagka ganun eh. Pag hindi equal yung total mo. If you are using the dollar sign, Okay, we are using different values kasi. So better manually input ang sa percent. So that will be equal sign chi-square test, which will be the total of the rows divided by the total of the column, and then times the total of the column divided by the grand total, or the total number. So in this case, we have the total for the rows is 80 divided by 60. This is the total of the column divided by the grand total, which is 200. Then you come up with 24. Anyway, the end result will be a chi-square test. So your chi-square test will give you the p-value, right? So the p-value that you will take will be 0.058787172, right? And the calculated value or the critical value is 0.05. So still you have to compare your p-value, critical value of 0.05 towards that calculated value, which is 0.05871. So 0.5871 falls within or outside rejection region.
Doc Tim.
Yes.
Doc, saan natin nilalagay dyan yung occurrence of respiratory illness? Kasi I don't know if you are going to allow me to show my table.
Yes, go ahead, Dr. Roel, please. Hey, Sir Ray.
Na-debunk yung
Sir Ray, naka-silent po kayo.
Sir Ray, naka-silent yata kaya. Hindi namin kayo marinig. Sir Ray.
Doc, sandali lang mo, Doc. I-ano ko ulit yung yung table. Doc, ito po yung ginawa kong table kasi.
Observe 80, 120.
Observe is sa smoking habits po, then respiratory illness, then yes and no na lang po yung ginawa kong table. And then sa expected po is the same. We need to calculate yung summation po ng nung expected, which is equals, and then the Q10 is the total of the column and times the total of the row, then divided by the overall total, which is the 400. And then yung kinumpute ko po yung chi-square test is ito po yung total po niya, yung ito lumabas po sa chi-square sa ano po is 0.03, which is below the alpha value of 0.05. Kaya sinabi ko po na reject the null hypothesis and accept the alternative hypothesis, which is there's a significant association between smoking habit and occurrence of respiratory illness.
Mali kasi yung inputs mo, Sir Ray. So observe, a total lang of 80 for smoker and non-smoker will be 120.
Yes po.
So nandyan kasi is 80 and 120. That should be 30 and 50 to make an 80 row total.
Okay.
Yeah. So that should be 80 instead of 200. Because smokers...
80 po yung smokers, di ba? Then 120 yung non-smokers.
All in all, 80 smokers. But among those smokers, how many of them developed respiratory illness? 30. Those who did not, 50.
Okay.
Kaya iba yung na-generate mo. So the total number of smokers is 80. and they are distributed as follows. 30 of them, okay, 30 of them develop,
Smoke, respiratory illness.
yes, and the rest of the 80, which is 50, did not develop. So that will be 30-50.
Okay po. Sige, sige, sige. Sorry po.
That would make a big difference.
Oo.
So for the respiratory illness naman, for the should be non-smoker. Ay madidin yung ano mo, yung yung groupings mo, nominal groupings mo. So
Kasi yung una ko pong
habits.
ginawa is the same with Dr. Rayuel. And
Yes.
then hindi ko din po kasi pakuha bakit wala siyang wala siyang correlation. Kaya iniba ko na din yung date. Sabi ko, paano ko ba ilalagay yung respiratory illness
So
na date
ito,
sa table?
if you can see your observed your contingency table for observed, okay, the row number 1 smoke that should be smokers, not smoking habits and respiratory illness. These are not the nominal groupings that you were presented. The nominal groupings will be smokers and non-smokers. It's not
Kasi parang hindi ko Doc,
respiratory
parang hindi
illness.
ko matanggap yung wala siyang correlation.
Yan na
Kasi
nga.
namatay yung tatay ko sa lung cancer, Doc.
Don't worry, these are hypothetical numbers. But yun nga. So kung yun yung challenge ninyo, so ibig sabihin, if you fight with numbers, you will never be wrong. Ito yung nakuha ko eh. So wala tayong magagawa. Pwede ko kayong i-dispute. So sinasabi nyo na smoking will result to respiratory illness. But don't take this very much in vain because these are just hypothetical numbers, no? So these are not actual na research na ginawa. Ginawa ko lang ito na hypothetical. So the thing is, ang lumabas sa research mo is no smoking. Smoking is not related to respiratory illness. So be it. Kasi yun yung nakuha mo eh. You cannot dispute that kasi I can show you the numbers. So yun lang ang gusto kong sabihin. But don't take it seriously. These are hypothetical numbers. The misleading yung magiging result nyo. But ang gusto ko lang kasing makita nyo is on how you're going to decide with numbers. Ha?
Sige po. Babalik ako dun sa first na ginawa ko.
This is not an actual research. These are hypothetical numbers. Para lang may ipakita kung may pakita kung paano kayo mag-compute. But then, just in case, kunyari, this were true results, okay? And it came out na yung conclusion may smoking is not really related to respiratory illness. So, kaya nga research eh. So, this is the time that we are going to challenge what is known. So, what is known before is pag nanigarilyo ka, siguradong magkakaroon ka ng sakit. Okay? Now, you challenge that. You research another question. And you found out eventually that in this day and time, okay, the connotation of smoking and respiratory illness doesn't apply anymore because on your research, you established that smoking is not actually related to respiratory illness. So parang ganun lang yung principle na gusto kong ipaabot sa inyo if you have these numbers. No? This will help you decide things. No? So you research and eventually nakita mo yung paracetamol pala hindi na gumagana ngayon. Noon gumagana ang paracetamol, baka ngayon baka hindi na gumagana. That's why you want to evaluate things and you challenge them if those parameters before are still applicable today. So yun lang yun. But please, again, do not take the numbers seriously because these are just hypothetical numbers. Huh? So,
okay, Doc. Thank you, Doc.
So with regards to your contingency table, just be very particular on the nominal groupings. Kasi di ba ang chi-square is for nominal data. Ang groupings natin dito is smokers and non-smokers. And then the other groupings will be with respiratory illness and without respiratory illness. So yun yung contingency table mo and you should not be mistaken. Okay, any question with the chi-square? Yung chi-square nyo, makikita nyo yung numbers dyan, actually nominal. So we're just putting the smokers into group and non-smokers into group. So we know that there are 30 non-smokers and 30 ganun-ganon. So those are nominal. We are just putting them into group. That's why we use the chi-square. And then eventually, we would like to compare, no? Your expectations. Kasi yung expectations mo, katulad nga sabi ni Sir Ray, ang expectations niya is smoking will usually result to respiratory illness, when in fact, dun sa research niya, nakita niya na hindi pala ganon. So, yung expectations and the actual scenario are not related with each other. Okay, any more question po? Tripleng palakpak kina Doc Ray at saka kay Doc Roel. Yan, galing na. So, salamat, Dr. Astrid Ilangdo. Okay, so most probably you understood already, no? The chi-square. Any question? So dito hindi tayo nagko-compare, no? We are not trying to compare smoking and respiratory illness. In fact, we're just trying to see if they are related with each other. If smoking is related to the respiratory illness. So this is a relationship goal. So that's why we use the chi-square. No? So if none, can we proceed to the next test, which is the correlation? Yeah.
Yes. Good afternoon. Permission to
So kami ikaw
share.
ba yung nagtatanong kahapon doon sa chi-square?
I know, Doc. No.
Hindi. Okay.
Yeah. So, good afternoon. I'm tasked as the group. I'm tasked as the group reporter today, pero I'm scared po, Sir Team, kasi I'm not very confident with my report. But I'm doing the best I can on the way I understand our lessons po.
Yes.
And I'm willing to accept corrections if needed.
No
Okay.
problem, Doc. Go ahead.
So play. Yeah.
Good afternoon, classmates. We are from Bohol Group 2. You're given a scenario where we are the chief of the professional medical services. We require 20 medical officers to undergo ACLS certification to become future trainers of our hospital. We studied the relationship between the number of hours spent studying for the certification exam and the final exam scores of a group of doctors who took the ACLS certification. These are the steps in hypothetical testing. First, we will organize our data. So here, we plotted our data. We have the students 1 to 20. They are studied and their corresponding scores. First, we will generate our descriptive statistics by clicking our input range and output range. So here, we have the input range and the output range. And then the Excel will automatically give us our summary statistics. Okay, so with here we can see our mean, median, mode, range, minimum, and maximum values. Next, we will create a mean range. This is done with the following formula: equals the mean minus 3 standard deviation, 3 times standard deviation. Then we compute the second row, which is the mean minus 2SD, which will be computed by equals the F5 and so on and so forth. Okay, so that's the mean. The mean is 80.65. And then we compute for the mean plus 1 standard deviation. and then mean plus 2 standard deviation, and then lastly, the mean plus 3 standard deviation. Third step is to create our histogram. So we click the data analysis icon, then histogram. So we click the input range, which are the exam scores, and the mean range. Then our output range. So this is our histogram with the mean and corresponding frequency. The last step is to insert a bell curve. So this is done by inserting a scatter plot. So insert, then scatter plot icon, and then this one, and then there. The scatter plot is given, and then we will change our minimum value to 55 and maximum value to 115. And this data gave us a negative skewed bell curve with skewness value of negative 0.3327283. So next, the second step is to state our hypothesis. Our null hypothesis is there is no significant relationship between the number of hours spent studying for the certification exam and the final exam scores of a group of doctors who took the ACLS certification. Our alternative hypothesis, there is a significant relationship between the number of hours spent studying for the certification exam and the final exam scores of a group of doctors who took the ACLS certification. Then we get our level of significance and critical value. To do this, let's click the data analysis icon, then t-test pair to sample for mean. Input variable 1 for the hours studied and variable 2 for the exam scores. Then the Excel will give us automatically the critical value, which is the t-critical two-tail value, which is 2.09, and our p-test, which is 5.80899 exponential negative 19, or our p-value is 0.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 is 0.05. If the value is less than 0.05, we will reject our null hypothesis. If the value is more than 0.05, then we will accept our null hypothesis. Our value is 0.00000, so there are 18 zeros, 58089, and this is less than 0.05, so we will reject our null hypothesis. So next step is to choose our statistical test. So correlation analysis is a statistical method used to measure the relationship between two variables. So in correlation analysis, we usually want to know two things. First is how strong the correlation is, and the second is in which direction the correlation goes. So this is just a review. So we can read or get both of these by getting the correlation coefficient, which is between -1 and 1. So first is how strong the correlation is. So there are many ways to know how strong the correlation is. Popular are Pearson correlation coefficient, Spearman correlation coefficient, Kendall-Stowe, and point-by-zero correlation coefficient. So our task is to understand Pearson correlation. So there are two ways to get this: the tedious mathematical way, which is by this formula, or the magical way of using the Excel. So the strength of correlation can be read in a table. When the result is between 0 and 0.1, so we speak of no correlation. If the R is between 0.1 and 0.3, so there is low correlation. Between 0.3 and 0.5, there is medium correlation. And between 5 to less than 0.7, this is high correlation, and 0.7 to less than 1, this very high correlation or very strong correlation. So next is we want to know in which direction the correlation goes, and this can be easily determined by using our Excel by clicking the Insert tab in the Charts group and click the scatter symbol. A positive correlation exists when high values of one variable go along with high values of the other variable, or when small values of one variable go along with the small values of other variable. A negative correlation exists when high values of one variable go along with low values of the other variable. So again, on our data, first we want to know how strong the correlation is. So in order to do that, we use our friendly Microsoft Excel. So first we click the data analysis icon, then correlation on the correlation analysis tool. Then we identify our input range, which is from cell B1 to cell C21, grouped by columns, and then check labels in the first row and identify our output range, in this case, cells E10 to G15. So the correlation coefficient is given, which is 0.966487502. When we plot the results, table R equals 0.9, speak of a very strong correlation. Now we want to know which direction the correlation goes. Again, we use our friendly Microsoft Excel. Click the scatter chart, and voila, the scatter plot is given. A positive correlation exists between the number of hours spent studying for the certification exam and the final exam scores of a group of doctors who took the ACLS certification. So we make a decision. Based on our findings, we will reject our null hypothesis and accept our alternative hypothesis. So in conclusion, long hours spent studying for the certification exam is correlated to high final exam scores of a group of doctors who took the ACLS certification. Thank you.
Very good, very good, very good. Okay.
Tama po ba, Sir Tim?
Oo, tamang-tama. And even you went beyond my expectations. Okay, so yung first part, ginamit na niya kaagad yung p-values, no, to decide for the relationship. Okay, so actually this is not an actual value that you are comparing if the relationship, no, kasi sabi nga natin there is no degree na different. We're just after if you study long hours, will it result to a higher score? So hindi naman natin pinag-usapan kung 3 oras ako mag-aaral, compare mo sa 5 oras, sa 6 na oras, meron kang patas ng patas yung scores mo. So that will be for regression. But what we are after is we just wanted to know if the number of hours affects the result of your exam. So dito, ginawa niya kaagad yung p-values niya. Okay? Anyway, if this comes out, you can stop at 0.000. So yung p-value is 0.000, which is comparable to 0.05. Still very, very small. Napakaliit ng value mo. So you must have been away from the margin. So that will prompt you to reject your null hypothesis. No? So that means when you reject your null hypothesis, meron pala talagang effect ang studying long hours to your exam result. And then the second na ginamit is the correlation, the values of R, raw. So meaning to say, may range yan. Ang range yan is from -1, middle at 0, then +1 on the other side. So we calculated the value of R. So let's proceed to the next slide, Doc Kapol. Sige pa. Yeah. So, no. Yeah. Okay. Kahit yung second na lang para mayroon tayong basis. Yung 29, number 29, Doc Kapol. 29. Yeah. So nakita niyo dyan, the value of R, okay, the exam score, the hours studied is 1. Almost positive 1, no? Yung exam ng scoring mo is almost positive 1. So napakadikit nila. It means they are strongly related because they approximate almost 1, positive 1. Okay? So the direction is positive, so you're going up. So it shows a very, very, very strong correlation. So the closer you get to positive 1, the higher will be the relationship. The stronger will be the relationship. And since the value of R, okay, in your exam or in your scenario, even approximated 1 and the exam score is almost 1, which is 0.96, then that just goes to show that there is a very, very strong relationship between studying and examination result. Okay? Very good, very good, very good. Baka makalimutan natin yung palakpak natin kayo kahapon. Okay, any question with the correlation test? Okay, correlation test, most probably you'll be using your Pearson's. No? Pearson's is the most common. Okay, any questions? So again, we were able to establish a relationship using this statistical test. So it's very easy to make conclusion once you can generate the data. So any question pa? Any question with correlation? Again, relationship. No, we're just trying to establish relationship. We are not establishing the degree of how one can affect the other. Okay. Because if we want to know that, then we better proceed with the regression test. So, mukhang wala naman kayong well-explained naman. Let's proceed with regression test. Regression. So, who will be...
Pag-login lang po ako doon sa isang account, sorry.
It's okay, Doc Jo. So actually, yung data mo, di ba yung data mo is yung relationship ng dalawa, you can go straight using your Excel. You just click on the data set and then click the data analysis, go to correlation, and automatic magbibigay na siya ng R values. No? So there will be shortcut for that. But it's very good. Doc Apple showed you the better way of viewing and how to proceed with that.
Hello?
Okay, Doc Joe, please go ahead. Doc Joe, naka-mute ka ha?
Yes, wait lang po, Doc. Nagsiset po, Doc.
So, I am going to decide that I'm getting more and more confident that at least at this point of our discussion, lumilinaw na po ba sa inyo on how are we doing decisions in research?
Yes, Doc.
Lumilinaw na. So pag nagbabasa kayo ng mga research paper, makikita nyo palagi dyan confidence level. Makikita nyo yung test statistics, mga ganun. So that's what they are saying. No? So we are not deciding in terms of the absolute value, okay? But we are deciding on possibilities. So your research result are talking about what are the possibilities of getting this side or the other side of the hypothesis. No? So hindi natin sinasabi na one is greater than one is lesser than two, no? But what we're trying to do in research is we are going to identify if there is a difference between absolute numbers. Okay. So for the last test will be the linear regression.
We were tasked to report on linear regression. Why? And actually, lahat ng members ng group namin very apprehensive in reporting linear regression kasi parang very, very technical siya.
Really, I admit, this linear regression is very technical. Yeah, let's just see and we'll see where we can modify.
I will try my very best.
Baka naman nagawa mo ng sobrang galing, Doc Joe, so no problem.
So this is linear regression. This is used to predict the value of a variable based on the value of another variables. We are basically using a variable to predict another variable. So in those variables are the dependent and the independent. So na-discuss naman na natin to in the past, diba? The dependent is the one we want to predict, and the independent variable is the one we are using to predict the other variable's value. So this also estimates the coefficients of the linear equation involving one or more independent variables that best predict the value of the dependent value. So this is the case given to us. Being the medical director of your hospital, you are interested in understanding the relationship between the number of nurses on duty, which is the independent variable, and the number of patients treated in a day, which is the dependent variable. The nursing service requested to hire more nurses to meet the quality needs of your patients. They believe that having more nurses on duty may lead to an increased capacity for patient care. So you ask them to provide you with data on these variables over a week. You want to see if there is strong evidence that suggests the number of nurses on duty is significantly influences the number of patients treated in a day at the hospital. So this is the data that we've been given. So we have 6 data sets. The number of nurses on duty on this side, and the number of patients treated corresponding to the number of nurses on duty. So we want to know kung related ba yung number of duty na nurses do sa number of patients treated. So we will apply the linear regression model. So the hypothesis are the following. So the null hypothesis is that there is no significant relationship between the number of nurses on duty and the number of patients treated. So parang kahit na gaano karami pa yan, parehas lang din talaga yung number ng matitreat ninyong patients. So pro-admin yan na hindi nila dadagdagan yung number of nurses. But if our alternative hypothesis gets accepted, which states that there is a significant relationship between the number of nurses on duty and the number of patients treated, then we will have evidence to tell the management that yes, we have to hire more nurses because it translates to higher number of patients being treated. So we'll go through one by one yung steps. So the step 1 is to calculate x times y, x squared, and y squared. So all this we can do actually in Excel. Initially, ginawa ko siya sa Excel form, sa Excel na lang kasi mas mabilis siya actually. But it makes sense. It's not that difficult. Mukha lang siyang complicated at first, pero kaya naman. So kahit manual do, kaya naman din po.
Yes,
So
yes.
you have to get the x times y, the x squared, and the y
At
squared.
unless
So
yung mga data sets mo usually involves 1,000, 500, mayigit 500, I guess you have to use your Excel. But your data set is just 6, so
kaya
it's
naman do.
good. Napakaganda kung may pakita mo sa amin, Doc, on how you process things. Thank
So
you.
yung third column natin is x times y, no? So this one I calculated manually. So ito yung first step natin to calculate the values of these 3 columns. Step 2 would be to calculate this values. So the sum of x, the sum of y, sum of x times y, sum of x squared, and sum of y squared. So ito, pwede mo naman din i-input yan sa Excel kasi mas madali kaysa mag-enter ka manually ng numbers sa calculator. So this one I entered lang din sa Excel para mas madali na gawin. So once we have these values, the next would be to calculate B0. So this is the formula for this. So the sum of y times the sum of x squared minus the product of the sum of x and the sum of xy divided by the difference between these two values na present naman na dun sa previous natin na table. So magpa-plot na lang talaga tayo ng mga values. So this is the value that I got for B0, 11.85. And then there is another variable or another value that we have to compute. So this naman is the formula for that. So again, babalikan lang natin yung table na nauna natin na-calculate and we come up with 10.14. So, paano naman siya nagma-matter? So, ipa-plot na natin kasi siya dun sa formula. So, this is the, this is the formula. Parang similar siya sa y is equal to mx plus b, diba? Pag nire-arrange lang natin yan. So, yung value ng b0 tsaka yung b1, ipapalit lang natin dyan. Dun sa naunang mga na-compute na natin, multiplied by a constant x. So, yung x, yung value na present sa dataset natin. Yung original na x, ano lang tayo ng random na number na, 41, ganyan. So, pwede mo siyang palitan dyan. Tapos, makukompute mo na kung ano yung value ng y, which is the supposed number of patients being treated. Later on, I will show you an example. So, ito naman yung saan. Sorry, I'll end lang po and then I'll try to show na lang din how I did it sa Excel.
Yes, please.
Stop share. And then share again. Well, how do I do this? Share screen. Here. So, dun sa sa Excel, ay, sorry, based dun sa sa ginawa natin na linear regression na formula, hindi natin masasabi kung talaga may significant na difference or wala, di ba? Parang nakaka-come up lang tayo sa formula in predicting the value of one variable using the value of the other variable, but hindi natin masasagot yung tanong natin kung significant ba yung relationship nilang dalawa. So, this is where this comes in. So we have I typed here the value of the x and the y, and then we go to data, and then data and
Doc,
yes, Doc.
clarify mo lang, X represents the
Sorry,
independent.
yes, X represents the number of nurses on duty.
This is the independent.
Yes,
Y.
Doc. And then Y is the number of patients treated, which is the dependent variable.
Para malinaw natin yung Excel. Okay,
Right.
go ahead.
So we go to data analysis tab, and then we can click here, automatic na regression. No, tapos you just have to type in the y range and the x range. So I did this earlier para mas mabilis dalhin. So yung output range is where you want the output to come out. So I don't like this one anymore. And then this one. So lalabas na yung mga yan, mga values na sobrang dami na medyo mahirap paintindihan. Actually, na-discuss naman na po yung ANOVA kanina, di ba? Hello?
Yes.
Hello? Yes. Okay, so mabilis na lang. So lalabas po lahat yan, actually. Tapos,
That is your summary regression output.
Yes, this is the summary regression output. Itong nasa ilalim. Tapos may ANOVA table din kasi nalalabas dyan. Although na-discuss na yan siya kanina, pakita ko na lang din kung paano kung anong mabilis lang. Sorry. So, ito yung mga So, nabanggit na rin naman kanina kung ano itong mga to. So, multiple R is the correlation coefficient that measures the strength of a linear relationship between two variables. So, ito yon. So, one means a strong positive relationship. So, as we can see here, our multiple R is 1, almost 1. So, ibig sabihin, may strong positive relationship yung number of nurses on duty and yung number of patients na natitreat nila. So the closer it is to 0, wala siyang relationship at all. And if it's negative, strong negative correlation yung meron siya. So the coefficient of determination, this is the R square. So in our example, 97.9% of the variation in the number of patients treated may be explained by the number of nurses on duty. So again, parang sinasabi lang nito na very strong nga rin yung correlation natin na parang mas mataas talaga yung number of patients treated given the higher number of nurses on duty. So I don't know if I don't know, Doc, if I still need to go through all this.
No. It's okay. What I want you to remember on that basis, on that data, is your R square. R square. The most important is your R square. Okay? R square represents the coefficient of determination, which shows the goodness of fit. Meaning to say, 97.9% of the time, but the variation in your data, okay, can be explained by the number of nurses on duty. Ibig sabihin, near perfect ka. So, ang projection mo, maganda yung data mo. Meron kang na-elicit na relationship. So, you must have collected a good data. That's what it means with these regression statistics. For the regression statistics, well, it's okay to, tama ka, it's okay to take note of the multiple regression, which is 0.98. The closer it goes to positive 1, okay, the stronger the relationship. Ibig sabihin, yung mga data na na-collect mo must have been going the way you want it to be, na you want to show relationship. Okay, and your R square will just be the percentage on how your data sets reflects the possible effect of your projection. Yeah.
Okay, Doc.
So for the regression statistics, what you need to know is the R square and the multiple R, but
Doc.
basically the R square. And of course the observations. If you can see the underneath the observations, okay, that will double check the number of entries you have. So it is best to take note of that para compatible ba yung pinagko-compare. So those are the 3 things for the regression statistics. R
So I will
square.
skip this part, Doc, because this was discussed already.
Yes. So
the important lang dito is the p-value of the f. So the p-value is less than 0.05, which indicates that the explanatory variable number of nurses on duty has a statistically significant association with number of patients treated. So ito yung
can
coefficients.
you go back again, Doc Joe? So for your ANOVA, what is important there is the significance level. Okay, that's
Yes, Doc.
0.00152727. So at this stage, what is the significance level of your null?
0.05.
0.005. So you compare that with the significance of level of your test. So as early as now, can you deduct any conclusion?
Yes, Doc.
Yeah, that the significance level of your test is way below than your null hypothesis. So
we accept that.
yeah, we accept. No. You have to reject the null hypothesis.
So we reject the null hypothesis, yes, Doc.
Okay, which means that there is a significance. Okay, meaning to
Yes.
say you are on right track. Because probably you have taken a good variables already. So to proceed, to confirm more, you take a look at the coefficient levels. Okay, so what is important naman in coefficient levels?
So dito naman sa coefficient level natin, so familiar kayo siguro dun sa value na 10.14 because we already calculated this manually earlier. So ito rin yung value ng B1. I think if I'm not mistaken. So ito yung lumabas na value dyan. So
your coefficient, what is important is the x variable,
yes,
not the intercept. So you take a look at the x variable. That means positive 10. Positive 10. So meaning to say, there is a strong relationship going on with this stated data. Okay, please go ahead, Doc Joe. Sorry ha,
okay, Doc.
hindi natin makalimutan.
It's okay, Doc. Thank you. So we already mentioned this also. So ang important din dito is yung sa individual p-values tell us whether or not the explanatory variable is statistically significant. So we look at the p-value of the x variable. So we can see it that the p-value is 0.00015, which is less than the p-value of our null hypothesis. So we can say that it is statistically significant.
Okay, which means?
We reject the null hypothesis.
Which means?
We reject the null hypothesis, which means there is a relationship between the number of nurses on duty.
So totoo pala yung clinic claim na nurse supervisor mo na for every number increase of your nurses will translate to more patients.
More number, yes.
Right? Okay.
So this is the decision. We accept an alternative hypothesis that there is a significant relationship between the number of nurses and the number of patients treated. So how do we write this in the estimated regression? So this is just the same, no? If we are going to use it manually, we will compute it manually. Ganun pa rin natin siya isusulat. So alam lang dapat natin kung saang part ng output table natin siya hahanapin. So this is the same actually dun sa nakuha natin na formula dun sa manual. So basically pinahirapan lang natin sarili natin, pwede naman pala siya sa Excel. So for example, if there are 23 nurses on duty, we just plot it, no? Halimbawa, 23 yung X natin, di ba? So 10.14 times the value of X plus the constant. So ito yung magiging patients treated natin if there were 23 nurses na magjo-duty.
So that will be your projection, right?
Yes, Doc.
So you can project that for every 23 nurses, that would translate to a certain number of patients treated. Doc Joe, can you go back to the regression summary output?
Which one, Doc? In the Excel or the...
In the Excel. Sorry, in the Excel.
Okay, Doc. I'll stop sharing then.
So any question? Very good. Isang bagsak na palakpakan. Ang galing. Wala namang walang na-miss si Doc Joe sa kanyang So again, regression aims to explain the degree of relationship between two variables. And then you can project, eventually, you can make projections. So ilan ang kung magtitreat tayo ng ganitong number of patients, so ang tanong mo ngayon sa supervisor, or ang tanong sa'yo, kasi ikaw nag-compute, o ilang nurses ang idadagdag natin para maabot natin itong number of patients that we want to treat. So it gives you an idea on how you can project on the independent variables to produce the effect or the output, which is your dependent variable. Okay, so I just would like to go back for the summary output, no? So when you interpret this table, there are 5 things that you have to consider or to point out. Okay, number 1 in your regression statistics. Doc Joe, can you highlight it for me, please? You feel that. Okay, number 1 in your regression statistics, the most important is the R square. Yan. I-highlight natin ng yellow para yan ang titignan nyo palagi. Sa home siguro, home. And then field. Home. Field. So that would be yellow. Okay? Number 1 is you have to take note of the value of your R square, which means, you can transform that 0.97 into percentage. That gives you an idea that 97% represents the possible differences of your set of data. So, ibig sabihin, maganda yung projections niyo, possible projections na mangyayari. So the second one is the observation. Can you please highlight it again, Doc Mike? So you take a look at the observation. Okay? So that is important para magtali yung mga table nyo. Okay, so tapos na tayo sa regression statistics. Go to the ANOVA statistics. So what is important in ANOVA is the level of significance. Okay, the one highlighted in yellow. So this one will be the test. Okay, represents the p-value of your test. So if you compare it with the confidence level that you have, 0.05, compare it to 0.001. So you just have to imagine where it lies. So most probably this will lie outside the rejection region. So this will confirm all the more the relationship that you are having a good relationship, meaning to say there is a significance of that hypothesis na pag sinabi mong increase mo yung nurses, it will also translate to a more patient seen. Okay, so tapos na tayo. Huwag nyo nang tingnan yung mga ibang values. So for the next is your coefficient ratios. Coefficient level. Okay, in your coefficient level, what is important is your X. Okay, not the intercept. So the X represents whether this becomes positive or negative or close to 0. So your pag positive siya, it means you have a positive relationship, positive stronger relationship. If it is negative, then there will be negative relationship. Okay, after that, the last thing that you have to take note is the p-value. Okay, so the p-value of your X, which is 0.0001. Again, you use this p-value as the p-value of your test, compare it to the p-value of the population or the null. Okay, the null is 0.05. Your p-value of the test is 0.001. So if you imagine where it lies, most probably it lies outside the rejection region. So therefore, we will reject your null hypothesis, which means that Okay, alternate hypothesis states that there will be a significant, there is a significant relationship on the number of nurses and the number of patients that being treated. So that for every increase, for every 23 increase of nurses, kinumpute natin kanina yung projection ninyo, would translate to a certain number of patients that will be treated. Okay, so that's how your regression works. So it is a projection. It helps you project on your need kung ilang nurses pang kakailanganin nyo para maka-meet nyo yung stated number of patients that still needs attendance. Okay? So that's it. That's how easy your regression would be. So disregard nyo na yung mga ibang mga number dyan. It will not help you in any way being managers. For the seasoned statistician, this means a lot for them. But for us, we are just after the, again, number one, anong unang-una natin kinakailangan tignan dito sa regression? R square. Right? So the number one. Ulitin natin. In regression, what
Good afternoon. I'm Dr. Macalental po.
R square.
So you are
the observation.
7, 8,
The third is the significance level of your ANOVA. And then the fourth is the coefficient of the X. And then the p-value of the X. Okay? So with all those information, you can now generate a certain conclusion. Okay? Very good. So, bagsak na palakpak naman kay Doc Jo. Okay? Very, very detailed yung kanyang report. Okay. Any question with the regression? Before we summarize everything. Any question? Any question? Lahat tulog na? I hope hindi nyo tinulugan ito kasi ito na yung last session ninyo. Okay, with that, I would like to conclude this session and of course for the whole course. And this will be our last meeting. And I hope we learned a thing or two from our discussions. Well, expectedly, I don't expect you to learn everything in a single setting. No? So statistics needs practice. You just have to read. Ang technique dito para is since we're not after the computation, we're after the interpretation. Basa lang kayo ng basa ng mga researches. Then makikita niya pa-familiarize kayo with the terminology na ginagamit nila. Ngayon maintindihan niyo na, hindi na niya kayo malilito kung ano yung mga nilalagay niyang mga p-values doon sa mga researches. So it entails practice. No? You have to reinforce what we learn here because sabi ko nga, expectedly, we cannot teach you everything about statistics. No? So with the limited time and the course design that you have, it would be enough for you to understand the tenets, the principles of doing decision based on numbers. Okay? So with this, I would like to thank everyone for your presence and for your interest in this course. And thank you. And I hope to see you again some other time. So your next courses will be are already published. So be ready. Have your holiday for a while. Take your vacations. Enjoy the holidays. And then we will see each other again next year. Okay? So relax. And again, maraming salamat po sa inyo. Sana magkita tayo. Okay? So, reminders lang, meron pa kayong utang sa akin.
Yes, Doc Tim, thank you.
Yung mga assignments ninyo should be passed on or before December 10. Okay, just to give time for me to produce your grades para pagdating ng 15 days after ng course natin, makikita niyo na yung grades ninyo doon sa sa dashboard.
Doc, God bless po, Doc.
Thank you po.
Thank you,
Salamat.
Dr. Rin. Thank you
And
so
ano na lang,
much.
huwag mo na yata yung class picture for the last time.
Advance Merry Christmas po.
Advance Merry Christmas. Actually, Merry Christmas na, Dr. Ruel eh.
Happy holidays,
Happy
everyone.
holidays. Hindi namin kayo guguluhin ngayong Christmas, ha? So, next guguluhin natin next Bye.
Thank you, sir.
Thank you, thank you. I will see you on your graduation.
Yes, thank you, Dr. Rin.
Thank you, Doc. Thank you,
Thank you.
Merry Christmas, everyone.
Merry Christmas, Doc. Okay, so thank you, Dr. Argentina, for that very extensive discussion. No? So, very
Thank you
good.
po.
It,
Thank
it
you po.
warms it warms my heart, no? So parang nakikita ko na at least you're taking all the you're understanding the tenets of the statistics already. Okay? So thank you again. Thank you, everyone. Meron na tayong class picture, no? Meron tayong class picture. So if ever you happen to be kunyari dun sa inyo sa Mindanao, if you are close to each other and you decide to have group works or something, you can get some clips and videos of your group para who knows, at the on your graduation, gagawa tayo ng clips para sa inyo. Okay. So with that, again, thank you for staying with the course, and I hope to see you on our future classes. I don't know when, so but for sure, I will see you all in your graduation. Huh? So congratulations, you've gone this far. So we deserve a pat. Yeah, we've done it, right? So very good. So good luck, and see you again next time. So just a reminder, your assignments, please do them before December 10, on or before December 10, so that I can give you the your corresponding grades. So that we will deliver what is expected of us. Ayaw namin yung madidelay kami just because for some problem or another. Okay? Merry Christmas, everyone. And see you next.
Magpipicture muna tayo.
Hindi pa ba tayo tapos?
Wala pa po. Open camera, please, everyone.
For the surgeons, yan. May enjoy nyo na yan. Si Dr. Joanna, nag-ano ka ba? Nag-confirm ka? Hindi naman.
No, sir. Last year pa po.
Okay. So, you're on your fellowship. Sorry ha, na-disturb ko yung fellowship niya. So, bukas, magko-concentrate na tayo ulit sa PCS.
Dr. Mercado, pa-open po ng camera. Si Doc Romel.
Naka-open na, Doc Eds.
Dalawa
Open
yung
na.
gadget nyo, sorry. Okay.
Mababa lang yung, ano siguro.
Okay, 1, 2, 3, smile. Okay, next page, wait po Next page. Okay, 1, 2, 3, smile. Okay na po.
Gran! Regards po ako kay Jo. Bye-bye.
Hi, sir.
Okay. So, Merry Christmas, everyone. Merry Christmas. Thank you,
Merry
Dr.
Christmas, sir.
Merry Christmas.